Hello everyone, very good morning and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. Now guys, we are going to discuss ISRO 2020 electrical engineering answer keys. Okay, and we will share our experience with you and we will also give you idea how to solve the questions in ISRO examination, right? And definitely some student will ask about the date. So guys, it may be in last week of July, but once we will get the idea about the dates, then definitely we will inform you. So let me know that sound quality, picture quality, everything is fine first of all. Okay, then this is a ISRO 2020 electrical engineering answer key discussion, and GATE 2024 BYJU'S Premium League BPL for electrical, electronics and computer science branch. That is a YouTube app series starting soon on our channel. Okay, so please subscribe the channel, share the link of this session and like the session guys. Now again, that is the important information for you. Take a step towards success in GATE. If you want to start your journey with us, then this is a golden opportunity for you. National scholarship test for GATE examination and get up to 90% off on our program. That is 25th June 9 AM. You can register now for this. Guys, remember, I am going to discuss some important subjects. That is what network, analog and digital. Then Asu Jangra sir will join. And then after that, Naveen Golapalli sir will join. And then finally, Saket Verma sir will join. So stay tuned with us. We are going to discuss complete 80 questions from electrical engineering. Okay, and all questions are very important and you will get idea how to solve these questions guys. Now this is how I am going to start with what network, and around we are having 10 questions from network. Okay, and let me know that sound quality, picture quality, everything is fine guys. Please inform me about that. Yes please. Okay. Okay, now I think everything is fine. Then this is a network. That is first question. For a circuit shown below, calculate the value of I1. Okay, where is the I1? That diagram is given. One dependent source is given, that is called current controlled current source. 20 volt battery is given, 1 kilo ohm resistor is given, 10 kilo ohm, 10 kilo ohm and 10 volt, that is given. So there are two methods to solve this question, right? And then you have to find the I only. What is the I? I, that is the current through this battery, that is what, 0.7 volt battery. Okay, then we can solve. First of all, you can convert. There are two ways. You can convert it into what? Thevenin's equivalent. What is the Thevenin's equivalent of this? For example, if you want to get the value of the voltage, 10 divided by 10 plus 10, that is what, 5 volt. And what is the Thevenin's resistance at this point? First of all, remove this. Then this 10 kilo ohm and 10 kilo ohm are in parallel. So what is the RTH? 10 parallel with 10, that is what, 5 kilo ohm. Now very simply, you can convert it into this diagram. This is the 5 volt VTH and what is the RTH? 5 kilo ohm. Already I have calculated 5 kilo ohm. Now you can connect this diagram. This is 0.7 volt. And what is the current here? I1, that is required. Now this is the branch. What is the current here? 10 I1. What is the current from this branch? 1 I1. And that's why this total current is 11 I1. Total current is what? 11 I1, and that is connected to ground here. Right? If suppose one battery is connected here and one current source, then remember, we have to consider only the current source and apply the KCL at this point, 11 I1, and that is the 1 kilo. Now you can write a KVL from this point to this point. What is the KVL? Minus 5 plus 5 times of I1 plus 0.7 plus 11 times of I1 into 1. Now it will become 16 times of I1 is equal to 4.3. This is the 4.3. So what is the I1 is equal to 43 divided by 160. Which answer is correct? 43 divided by 160 milliampere. That first answer is correct, guys. Okay, so that is the one way to solve this question. What is the another way to solve this question? Let this is I1. Directly you can say, directly what you can say that let this current is what? I2. So what is the current here? I1 plus I2. What is the current here? I1 plus I2, guys. Okay, now you can apply a KVL here, and then finally once you are going to apply the KVL, what is the current here? 11 I1. 11 times of I1. Now you have to write the two KVL from this point to this point and second KVL from this point to this point, and you can find the answer for these two questions, because we are having the two unknowns. We are having the two unknowns, and that is the two way to solve the question. Now second one, second question, calculate the V1 for the circuit given below. What is the V1 for the circuit shown below? Okay, then where is the V1? This is the V1. Now how we can solve this question? Simply, this is the 2 ampere, this is V1. You can apply what? Mesh analysis, then it will become very easy for you. For example, this is the first mesh current I1. Directly you can give I1 is equal to 2 ampere. Then this is I2. What is the I2 is equal to V1? I2 will become V1. V1 is the dependent. It is a voltage controlled current source. Now you can assume that this current is I3. If this current is I3, so what is the V1? 3 times of I3. You have to calculate the V1. That is the equation number 1. 3 times of I3. 3 times of I3, and I1 is equal to 2 ampere and I2 is equal to V1. Now you can write a KVL here. Apply the KVL in upper loop. It will become 3 times of I3 plus 5 times of, what about the direction of the I2 and I3? They are in same direction. That's why you can write I2 plus I3. And then 2 times of, what is the I1 and I3? They are in opposite direction. Then you can apply I3 minus I1 is equal to 0. Now you can write 3I3 plus 5I2 plus 5 times of I3 plus 2 times of I3 minus 2I1 is equal to 0. This, that is 5 plus 3, 10 times of I3. Plus, what is the I2? I2 is V1. I2 is V1, and that's why 5 times of V1. Plus, right, minus, that is the 2. What is the I1? 2 ampere. That's why it will become 4. Is equal to what? 0. Now, what is the I3? I3 is what? V1 by 3, or what is the I1 is V1 is equal to 3 times of I3. So when we are adding the 3 times of I3, it will become 10 I3 plus 25 times of, because it is a I3, is equal to 4. This is, sorry, 15 times. And that will become total 25. So what is the I3? 4 divided by 25. 4 divided by 25 I3. So what is the V1? 3 times of I3. So V1 will become 12 divided by 25. That is the answer. In a simple way. Ashok, how are you? Very good morning, guys. And then let me, everything is fine? Yes, please. Now that is the another question. Okay, then 12 by 25 means what? Answer is D. Then third question. For the circuit diagram shown below, calculate the voltage across the capacitor at t equal to 160 microsecond. At t equal to 160 microsecond means exactly at t equal to 0, the switch will switch from position A to B. Once it is switched to position B, it is a source free response. Source free response. And what is the initial voltage across the capacitor? You can find from this diagram. So from this diagram, when this is connected, this capacitor will act as open circuit exactly at t equal to 0 negative. That is called steady state. So exactly at steady state, what is the value? 50 volt. Because the capacitor will act as open circuit switch is connected to A, and exactly at t equal to 0 negative, it will reach to what? Steady state. So what is the initial voltage across the capacitor? 50 volt. And capacitor does not allow sudden change of voltage. Now after that you have to consider this circuit only. This one. Remove this. Now circuit is connected here, B. To focus on this, this is a simple RC circuit. So what is the time constant RC? 80 into 2, that is 160 microsecond. And for source free circuit, what is the voltage across the capacitor? We see initial e raised to power minus t by tau. That is the equation for source free circuit. What is the initial voltage? 50 e raised to power minus t by 160 microsecond. Remember that time constant is in microsecond. And at which point it is asked? 160 microsecond means at one time constant. At one time constant, what is the voltage across the capacitor? It will become 50 e raised to power minus 1. As you know, that is 50 into 0.368. That is the e raised to power minus 1. Without calculator, you can find nearly equal to 18.4 volt. What is the answer for this question? 18.4 volt. B. Very simple circuit. Within 1 minute you can solve this question. Directly you can write without redrawing the diagram, guys. Okay. To like the session and share the link of this session. Okay, everyone try to give me the answer fast as possible. So this is the 18.4 volt. Next question. Consider the parallel RLC circuit having inductance of 10 millihenry. What is the value of the inductance? 10 millihenry. Capacitance of 100 microfarad. 100 microfarad. Determine the value of, 1 minute. Sorry for that. Determine the value of resistance that would lead to a critically damped response, guys. Critically damped response. So guys, we are having alpha is equal to what? Omega naught in case of network. Again, in case of control, we are having the zeta. Zeta is equal to what? 1 for critically damped response. But I am giving you the alpha is equal to omega naught. And what is the alpha for parallel RLC circuit? Parallel RLC circuit is 1 by 2 RC. Alpha. And what is the omega naught? 1 by root over LC. 1 by root over LC. Okay. Then from this is the condition for critically damped response. From this you can find the value of R. Then it will become R here. And then it will become 1 by 2C into root over LC. Right? This is R. Yes, 1 by 2 pi RC, and that is the value. And then you can find the value 1 by 2 LC and put the value, and you will get the answer. R is equal to 1 by 2 root over L by C, guys. Okay. From this you will get the answer 5. Check my calculation. Put the value of L, 10 millihenry. And put the value of what? 100 microfarad here and solve it, and you will get the answer 5 ohm. You are getting 20 ohm. 1 minute. Check my calculation. Okay, I am going to calculate it. R is equal to 1 by 2 root over L. What is the L? 10 into 10 raised to power minus 3. What is the C? 100 into 10 raised to power minus 6. This will become 1 by 2 root over. That is what? 10 raised to power minus 4. Okay, and 1 minute. This is the 10 raised to power minus 4. It will become what? Yes, 100. That is the 10 by 2. 5. 5 ohm is the answer for this particular question. Parallel resonance circuit. Okay, so this is the, for parallel resonance circuits, what is alpha? 1 by 2 RC and 1 by root over LC. The next one. Next question, guys. Next, in the circuit shown below, steady state was reached when the switch S was open. When this switch S was open, then the circuit reached to what? Steady state. Then, when the switch S was open, the switch was closed at t equal to 0. The initial value of the current through the capacitor 2C. What is the initial value of the current through the capacitor 2C when the switch is closed? You have to find the IC here. Now, so exactly at t equal to 0 negative, circuit reached to steady state. For DC transient, inductor acts as short circuit and both the capacitor will act as open circuit. And this is the 2C and this is the C. Guys, now this is the 2 ohm, this is the 4 ohm. Inductor does not allow sudden change of current, capacitor does not allow sudden change of voltage. From this point to this point, what is the voltage exactly at t equal to 0 negative? According to voltage division rule, Vx is given by 4 divided by 2 plus 4 into 18. 18. That is nothing but 12 volt. What is the voltage across the capacitor? 12 volt. It does not allow sudden change of voltage, guys. Okay. Now, second important thing, what is the voltage across this 2C capacitor? The 2C capacitor, it is given by voltage. According to voltage division rule, voltage across the 2C is given by C upon 2C plus C into 12. That has become 3 volt. Voltage across this capacitor is 3 volt. Total voltage is what? 12 volt. And what is the current through the inductor? But it is not required. But you can find what is the initial current through the inductor. That is 18 divided by 6. 18 divided by 6, that is the 3 ampere. This is the current through the inductor, guys. Okay. Then finally, now this is, now the switch is closed here. Switch closed, but capacitor does not allow sudden change of voltage. So what is the voltage across this capacitor? 3 volt. That is, sorry, this is a 4 volt, not 3 volt. This is divided by, this is the 4 volt. Calculation mistake. 12 divided by that is the 4 volt. This is the 4 volt. And what is the total voltage across this capacitor? 8 volt, because it is voltage division rule. 4 plus 8, what is the voltage at this point? 12 volt. You have to find the current here, IC. Then this current I is divided into two parts, I1 and IC. I is equal to I1 plus IC. I is what? 18 minus 12 divided by 2. 18 minus 12 divided by 2 is equal to I1. I1, what is the voltage? Parallelly connected, 4 divided by 4 plus what? IC. Then this is 6 by 2, that is the 3 is equal to 1 plus IC. So what is the IC 0 plus? IC 0 plus is nothing but 3 minus 1, 2 ampere. 2 ampere is the answer for this question, guys. 2 ampere. Okay. So this is the question C. Current through the capacitor. Through what? 2C. The next one, next question. So in this way we can find, always remember this is a transient. For DC transient, inductor will act as short circuit, capacitor will act as open circuit. And this is the question on initial condition only, because you have to find the value for t equal to 0 plus. Normally in second order circuit, question will be on initial conditions. Next question. Source Vs has 200 cos omega t, delivers power to a load at power factor of 0.8. What is the power factor? 0.8 lagging. And that is nothing but cos theta. Cos theta is equal to 0.8. You can find what is the sin theta. Sin theta is equal to root over 1 minus cos square theta. So from this, put the value, get the root of that, you will find 0.6. This is the value of the sin theta. Okay, this is the power factor lagging, means it is an inductive circuit. What is the value of the Vs? 200 cos omega t. So what is the peak value of the voltage source? Or we are saying, simply saying Vp. Vp is equal to 200 volt. This is given. So what is the RMS value? Vrms equal 200 divided by root 2. 200 divided by root 2. What is given? Reactive power is given. You have to find the active power. What is the reactive power? Means what? Vrms, Irms into sin theta is equal to 300. Okay. Vrms is known, sin theta is known. You can find the Irms. So what is the Vrms? So this will become Irms is equal to 300 divided by Vrms into sin theta. Okay. Now finally, what is the power here? Then V active power. Active power is nothing but Vrms, Irms into what? Cos theta. Now you can put what is the Vrms? 200 divided by root 2. What is the Irms? From this you can write the value. 300 divided by Vrms into sin theta. Vrms sin theta into cos theta. Guys, what is this? This is cancel out and you can find 300 into 0.8 divided by, now you can make shortcut. Yes, this is the 400 watt. Directly you can use this shortcut, cos theta upon sin theta, that is equal to reactive power. Right, or simply V reactive by tan theta. In this way you can directly find the value, guys. Okay, this is a very easy question. Then this is a 400 watt active power. Okay, then next question. Next one. So Ashok, what is the answer for this question? Try to solve this. Okay, then an ideal constant current source is connected in series with an ideal constant voltage source. This is again a very easy question. If we are going to connect a current source with a constant voltage source, these two are connected in series, then always it is equivalent to what? Current source. Effective is what? Current source. Right? Now you can connect a particular network here. If suppose we are connecting a current source and a battery, and let this current source is of 2 ampere. What is the current enter into that network? What is the current enter into this network? 2 ampere. It doesn't matter what is the value of the voltage source. It may be of 5 volt, it may be of 10 volt. But current enter into this network will be what? 2 ampere, guys. That's why it is effectively current source. So here current source, that is constant current source. Combination will be a constant current source. So B is the correct answer. Your answer is correct, Ashok. Then calculate the C equivalent of the circuit given below. What is the C equivalent of the circuit given below, guys? Okay. When I want to calculate the C equivalent, simple series connection and what? Parallel connection. What is the series connection? C1 C2 upon C1 plus C2. That is called series connection, C equivalent. And what is the parallel connection? In parallel connection, simply you have to add the value of the capacitance. You have to add the value of the capacitance. Now watch this. 2, 2, 12F. 2, 2 and 12F means what? These three are in series. So 2 series with the 2, it will become 1. And 1 series with the 12, it will become 1 into 12 divided by 12 plus 1. That is nothing but 12 by 13 farad. What is the equivalent of these three? 12 by 13 farad. And what is the equivalent of 8 and 5 in series? 8 into 5 upon 8 plus 5. That is 40 by 13. 40 by 13. So this 8 by 5 is 40 by 13 and this is the 3 is what? 12 by 13. Now these two are connected in parallel, guys. If these two are connected in parallel, so what is the C up to this point? C1. Just I am giving the C1 up to this point is given by 40 by 13 parallel with 12 by 13. That is nothing but 52 by 13. And what is the 52 by 13? 4 farad. So for this portion, what is the capacitance? 4 farad. Chinmay, very good morning. Now you can convert, remove this and it will become 4 farad. Okay, and this is 1 farad. Up to this point 4, 4 and 1 and this is 5, and this is what, 7. Now what is the C equivalent you have to find? Now 4 and 4 are in series, that is the 2 and 2, 1 in series. So what is the equivalent? 2 into 1 divided by 2 plus 1, that is the 2 by 3. This is the 2 by 3 in parallel with the 5. So what is the C2 here? C2 will become 5 plus 2 by 3. That is 17 by 3. Now, this 17 by 3 and 7 are in series. 17 by 3 and 7 are in series. Guys, find the value. 17 by 3. Okay. So now you can multiply it. 3, 3 cancel. 119 by 38. So 119 by 38. This B answer is the correct. B is the correct answer. But this is a very easy question. But normally students are doing the silly mistakes or calculation mistake, guys. Or what, series connection or parallel connection. Just they will consider capacitor like what, resistor. I think now this question is clear to you. So quickly I have solved this. So this is the 119 by 38 farad answer. Then the voltage across 2 Henry inductor is 6 cos of 5t. Voltage across an inductor is 6 cos of 5t. Determine the resulting inductor current at t equal to pi. If the inductor current at t equal to minus pi by 2 is 1 ampere. Minus pi by 2 is 1 ampere. It is given information. Okay. Now, Chinmay, what is the answer for this one? Okay. So please give me the answer for this question. Now let's try to understand what is the current through the inductor. Current through the inductor is given by 1 by L integral of V dt. Right? 1 by L integral of V dt. But when suppose we are going to integrate it, definitely we are getting some constant. What is this? I is equal to 1 by L. What is the L here? L here 2 Henry. 1 by 2 integral 6 cos of 5t dt. Right? Plus k. That is called initial value. Now, when we are going to integrate it, what is the integration of this? That will become 6 divided by 2 into 5 sine of 5t plus k. That is nothing but 0.6. This is 0.6 sine of 5t plus k. Okay, I. Now, what is the information is given exactly at pi when the value of t is minus pi by 2, sorry. Minus pi by 2, it is 1 ampere. Minus pi by 2, it is 1 ampere. Put here, this is 1 ampere, 0.6 sine of 5 minus pi by 2 plus k. Okay. Now, from this, you will get the minus this 0.6 volt. Okay. This is the, you can check. This is the 0. What is the value of the 5 of minus pi by 2? This is the odd multiple of that. And that is minus. And then it will become minus, and this is 1 plus 0.6, 1.6. K will become 1.6. K will become 1.6, guys. Now, once you will get the value of the K, then the I is become this value. This is 0.6 sine of 5t plus what? 1.6. Now, exactly at t equal to pi, this term will become 0. So, what is the I is equal to 1.6 ampere. That is the answer. 1.6 ampere is the answer for this particular question, guys. Okay. Now, next question. Determine the inductor voltage V in the circuit shown below for t greater than 0. What is the, this time inductor voltage is asked, and what is this? The switch will be open at t equal to 0. Means initially the switch is closed. When the switch is closed, circuit will reach to what? Steady state, 0 negative. And you have to find voltage for t greater than 0, means we have to find the equation. Okay. When the switch was closed at 0 negative, circuit is in steady state. For DC, inductor will act as short circuit. So what is the current through the inductor? The voltage at this point is 10 divided by 4. So what is the IL0 negative is equal to IL0 positive is equal to 10 by 4, that is the 2.5 ampere. And remember, inductor does not allow sudden change of voltage. Okay, sorry, sudden change of current, that is the 2.5 ampere. Now this switch is open. Remove this switch. We are having this circuit 4, 6 and inductor only. So 4, 6 for inductor means this is 6, this is 4 and this is the inductor, and already that is the current in this direction, and we are having the initial current 2.5 and this is the V. Polarity it is given 4 and 6. First of all, find the time constant of the circuit. Tau is equal to L by R equivalent. L is 5 Henry, R is 6 plus 4, 10, that has become 1 by 2. Now what is the equation for the current? IL is equal to IL0 e raised to power minus t by tau. Why? Because it is a source free, no source is connected. Then it is the 2.5 e raised to power minus 2t, because tau is equal to 1 by 2. That is the equation for the current. But equation for voltage is required. So what is the equation for the voltage? V is equal to L di by dt. L di by dt. What is the value of the L? 5 Henry. D by dt of 2.5 e raised to power minus 2t. Now when we are integrating 5 into 2.5 into what? Minus 2. Differentiate it. That is become minus 2 e raised to power minus 2t. 5 into 2, that will become minus 25 e raised to power minus 2t. Volt. Minus 25 e raised to power minus 2t volt. This is not 2.5 or so. Please be careful about that. 25. So minus 25 e raised to power minus 2t. This is the answer for this particular question, guys. Okay. So because the inductor will what? Discharge. Remember, conceptually remember, when the inductor will deliver the energy, that polarity of the voltage will be negative. Means actually what is the voltage polarity? Plus minus, and current enter through this. When the current enter through the minus, leave the plus, it will deliver the energy. It will deliver the energy, and that's why we are getting the negative value, right? That's why we are getting the negative value, and then you can find the answer. Okay. Then guys, this is all about the network. Now I am going to start what? Analog. So already I have discussed the 10 questions. So quickly you have to solve these questions in what? Coming ISRO examination. Okay. So be quick. I think your preparation is already done. Now it is time to solve the questions, guys. Okay then, next, analog. Now first question, the Schmitt trigger circuit shown in the figure below uses the Zener diode with VD is equal to 0.7 volt. Zener diode with VD means when the diode is forward biased, it will provide the 0.7 volt, right? Or what is the Zener Schmitt trigger circuit in uses with? If the threshold voltage V1 is 0, hysteresis voltage VH is equal to 0.2 volt, then what is the R1 and R2 and VR? You have to find the VR. What is the reference voltage here? What is the reference voltage here, guys? Okay. Oh, 1 minute. Okay then. Now guys, try to understand. What are the threshold voltage? This is a very standard diagram for what? Schmitt trigger circuit. Normally we are having the plus V set and minus V set. But because of this Zener diode, when we are connecting the Zener diode, output is limited. Output is limited to what? VZ and minus VZ, right? And this is given VD. If this is a practical diode, then we are having, suppose this is the diode. So if this diode is forward biased, then this diode is what? Breakdown. If this is the VD and this is the VZ, so what is the total voltage? VZ plus VD. VZ plus VD, that is called positive voltage, and when it is negative half, then it will become minus of VZ plus VD. That is the range of the output voltage, guys. है ना? Then so so the Asu Jangda sir will give you the idea about that. Just after me, the Asu sir will join and he will inform you about that. Now this is the VR. As you know, what is the upper threshold and lower threshold? Upper threshold voltage, it is given by V naught, that is the positive value. That just I am giving you the standard answer. Positive value of the output into what? R2 upon R1 plus R2 plus VR R1 upon R1 plus R2. VR R1 upon R1 plus R2. What is the lower threshold? V positive R2 upon R1 plus R2. This time this same value will become negative because we are having the same value, positive and magnitude is same. That's why this value will become negative. And this will become VR R1 upon R1 plus R2. This will remain same. Now what is the hysteresis voltage? Hysteresis voltage is V upper threshold minus V lower threshold. And that's why you will get 2 times of V positive R2 upon R1 plus R2. R1 plus R2. And then this value is given. Hysteresis voltage, what is the hysteresis voltage is given as 0.2 volt. Hysteresis voltage is given as 0.2 volt. So from this R2 upon R1 plus R2, you are getting the 0.2 volt. Now 0.2 divided by that 2, that will become what? 2 divided by 0.2. It will become 10 times of V positive is equal to R1 plus R2 upon R2. Right? And that is 1 plus R1 by R2. So what is the R1 by R2? 10 V positive minus 1. 10 V positive. This is the value, means positive value of that voltage source minus 1. That is the formula. Then what is the another information that is given in the question? If the threshold voltage V1 is 0 and the hysteresis voltage is this, then what is the R1 by R2 and VR? Now how we can find the value of the VR? Then you can find the value of VR by any equation. By what? This equation or what? That equation. That is what called reference voltage, guys. So then in this way we can find. But first of all, remember, what is the threshold voltage V1? First threshold voltage is 0, it is given. If the first threshold voltage is 0, so we can equate it towards 0. We can equate it towards 0. That is become R2 by R1 plus R2 plus VR R1 upon R1 plus R2. Equate it towards 0 and then put the value of V positive, R1 plus R2 cancel, and then you can find VR is equal to minus of V positive R2 by R1. Minus of V positive R2 by R1. So what is the 1 minute, what is the data it is given, the threshold voltage? I will check and then I will inform you about that. In question I think one data is missing. I think what is the Jenner diode voltage, it is missing. That formula, please go through that. Please go through that. 1 minute. Okay. If we are using the Jenner diode with VD is equal to 0.7 volt, then if we are using the 0.7 volt, then what is the answer? You can check. If it is given, then what is the value? 0.7 in positive half and minus 0.7 in negative half. Then you can put the value and then you can find the answer, guys. Right? So this is the value. Okay. So this is the way to solve the question. I think now it is clear to you. So what is given? 0.7 volt, only one diagram. 0.7 is given. Hysteresis voltage is 0.2. Then check this answer. That is the 2V positive R2 by R1 plus R2. Yes. That is 2 divided by, that is the 0.2. That will become 10 times of V positive upon R1 plus R2. That is 1 plus R1 by R2. Right. Okay, R1 by R2 is equal to 10 V positive minus 1. Then 1 minute. This I think that 6 volt, that is the Zener diode voltage. Sorry, 6 volt is the Zener diode voltage, VZ. It is missing in this question. 6 volt. Okay, 6. That's why the positive voltage will become, output positive voltage will become VZ plus VD. So that will become 6 plus 0.7, that is what, 6.7 volt. And what is the negative voltage? Negative voltage will become minus of 6 plus 0.7, that is the minus 6.7 volt. Yes, now put the value here, 6.7, it will become 67 minus 1, that is you are going to get the 66 answer. So R1 by R2 is equal to 66, and then you can find a value of VR, that is, this one already I have given, minus V positive, right? V positive is what? 6.7, and what is the R2 by R1? That is you are getting the 66. 1 by 66. So nearly equal to what? Minus 0.1 you will get. Minus 0.1 you will get this answer. So which answer is correct? This is. C is the correct answer for this particular question, guys. That is the question on Schmitt trigger. So, but you have to remember what the formula for the upper threshold and what lower threshold, guys. Okay. The upper threshold and lower threshold. Then, just I am concluding. Finally, this is the standard circuit. Always use the upper threshold formula minus lower threshold formula to get the hysteresis voltage. For upper threshold, use what? V set or V positive value R2 by R1 plus R2 plus VR upon R1 plus R2, and V lower threshold is given by V set R1 with minus R1 plus R2 plus VR R1 upon R1 plus R2. If any Zener diode combination is connected, then V positive value will become VZ plus the drop across the diode. V negative value will become minus of VZ plus drop across the diode. That is the value, guys. Now, next question. Consider the electron and hole mobility of germanium at 300 degree Kelvin, right? 0.36 and 0.17 respectively. Hole and electron concentration of this much. Find the conductivity of the germanium. Yeah, this is a very simple formula. Sigma is equal to what? NQ mu n plus PQ mu p. If the electron and hole concentration are same, that is called intrinsic carrier concentration. N is equal to P, both are same. Then this formula will become NIQ mu n plus mu p. Please use this formula and find the answer. Put the value 2.7 into 10 raised to power 19 into 1.6 into 10 raised to power minus 19. This is the concentration, that is the charge of the electron. Mu n, that is what? Mu n is 0.36. Always the mobility of electron is greater than mobility of holes. Without the use of calculator, this is cancel out. And then you can find the value. I think you will get the 2.3 mho per meter. Right? You will get the 2.3 mho per meter. This is the conductivity. This is a very easy formula. Use this. Next one. Technology CMOS used for fabricating integrated circuit. What is the CMOS technology? यार एकदम इजी क्वेश्चन आगे देखो. इलेक्ट्रिकल ब्रांच. कॉम्प्लीमेंट्री मेटल ऑक्साइड सेमीकंडक्टर. Complementary metal oxide semiconductor CMOS. So get the idea about the MOSFET, metal oxide semiconductor field effect transistor. What is the EMOS, enhancement MOSFET, DMOS, depletion MOSFET, and so on. And that is what CMOS. CMOS, complementary metal oxide semiconductor. Okay, then next one. A power supply having the output resistance of 1.5 ohm. Power supply means this is the power supply. Its output resistance is R. Normally it is called RTH. This is called VTH or VS or RS. And that is given as 1.5 ohm. Right? Full load current to a 50 ohm resistor. When we are connecting the RL. We are getting the 500 milliampere as a full load current. Full load current. And when the current is maximum, RL is what? Minimum. When the current is maximum, RL is minimum. Determine the percentage voltage regulation of the supply. Percentage voltage regulation. Percentage voltage regulation. I am giving you the shortcut. But remember, what is the formula here for percentage voltage regulation? Percentage regulation is equal to no load voltage minus, percentage regulation, no load minus full load upon full load into 100%. Right? Now, from the diagram, what is the full load voltage? VTH, this is the RL minimum upon RS. So you can give the full load voltage when there is a full load current. It is given by VTH RL minimum upon RS plus RL minimum. And what is the no load voltage? No load means when there is open circuit. When this is open circuit. So what is the no load voltage? No load voltage is VTH. No load voltage is VTH. Means there is no current. This is called no load voltage. Put the value no load voltage and full load voltage, and upon full load you will get percentage regulation is equal to RS upon RL into 100%. RL minimum. Okay, then find the value. What is the ideal value of the percentage regulation? Percentage regulation RS. RS is 1.5 divided by what? 50 into 100%. It will become 3%. Answer is what? 3%. You can directly use the percentage regulation is given by RS upon RL minimum into 100%. Within 30 seconds you can solve this question. And what is the, everyone please give me the answer in comments box. What is the ideal value of the percentage regulation? What is the ideal value of the percentage regulation? Okay then. Next question. So find the voltage Vin for the circuit shown below. Vn, here negative. This is the terminal. At this terminal you have to find the voltage, guys. Now, if this is the diagram given, how can we find the voltage? If nothing is given means ideal operational amplifier. If the ideal operational amplifier, and we can apply the virtual short concept. So what is the Vn? Vn will become Vn and V1. These two voltages are equal. And that is, what is the voltage at this point? 10 upon 10 plus 20 into V0. 10 upon 10 plus 20 into V0. So what is the value of the Vn? That is nothing but V0 by 3. V0 by 3. Now, when I am writing the V0 from this point to this point, write down the KVL from this point to this point. So this is the 6 volt plus V1. What is the V0? 6 plus V1. And what is the V1? V0 by 3. 6 plus V0 by 3. V0, 1 minus 1 by 3 is equal to 6. That is 2 by 3 V0 is equal to 6. Tell me, what is the V0? V0 will become 3 into 6 divided by 2. That is the 9 volt. What is the V1 will become? What is the V1? V0 by 3. V1 or Vn is equal to what? V0 by 3. Volt. So apply the formula. Apply the formula and you will get the word 3 volt. Yes, you have given the right answer, 3 volt. Equate these two terminal and find the voltage at this point, and then you can find the value here. Okay. In this way you can check this. You can check this value. Right. Now, next one. Next question. Power, this is again a very easy question for electrical student. Power BJT has a collector current IC is equal to 20 ampere. This value, normally in normal BJT, what is the range? Milliampere. But we are dealing with the electrical. So this is a power BJT. Power BJT means that will be used in what? Power electronics. That's why that value is very high in ampere, 20 ampere. IB is what? 2.5. Otherwise it is in microampere. And reverse saturation current is again, it is in very high, 15 milliampere. Find out the current gain beta. Find out the current gain beta means you have to use this formula. IC is equal to beta IB plus 1 plus beta times of ICO, or IC is equal to beta times of IB plus ICO plus ICO. This is the common. You can take the common, and then what is the beta is equal to IC minus ICO divided by IB plus ICO. And that is the formula. Now you can put 20 ampere minus what is this 15 milliampere, negligible as compared to this, minus 3, convert it into ampere. What is the IB? 2.5 plus what? 15 into 10 raised to power minus 3. You have to consider it. Otherwise, if you are neglecting this and that, so 20 divided by 2.5, you will get the answer 8. But answer is not 8, less than 8. So which one is the less than 8? 7.95. This is the answer. From this you can find the value of the beta, 7.95. So bilkul your answer is correct, 7.9. So guys, you want if anything extra, then write down in the comments box, right, what you want for the ISRO examination, right, for coming examination, because we have around 1 month. If you want some sessions, if you want some details, if you want to get the detail about some particular topic, then you can give the comments. And please stay tuned with us, because after that Asu Jangra sir will join, and then what, Naveen Golapalli sir will join, Saket Verma sir will join. We are going to discuss the complete paper. Okay. Then 100 picofarad capacitor has maximum charging current of 150 microampere. What is the slew rate of the capacitor? What do you mean by the slew rate, guys? Okay, tell me. What is the slew rate of the capacitor? There goes slew rate. 100 picofarad capacitor has a maximum charging current of 150 microampere. What is the slew rate? That is maximum charging current is given. Now remember guys, what is the slew rate? Slew rate means maximum rate of change of voltage. In case of operational amplifier, we are saying that maximum rate of change of output voltage. But in this case of capacitor, that is what is the maximum rate of change of the voltage across the capacitor. So what is the voltage across the capacitor? As you know, voltage across the capacitor is given by 1 by C integral of I dt. What is the rate here? dV by dt is equal to what? I by C. That is the rate. And that rate is given because the current is maximum. Maximum charging current. If the current is maximum, guys, then what about, because the value of the capacitor is fixed. Current is maximum means that rate is maximum. And this maximum rate is called what? Slew rate. So what is the slew rate? It is given. What is the slew rate? It is asked. This is the slew rate and this is maximum. Why it is maximum? Because the current is maximum. Current is maximum, guys. I maximum by C. What is the I maximum? 150 microampere minus 6 upon C. 100 picofarad. 100 pico means 10 to the power minus 12. It will become 1.5. It will become 10 to the power 6. So 1.5 into 10 raised to power 6 volt per second. That is the unit. Volt per second. But normally what is the unit of the slew rate? Volt per microsecond. So we can write 1.5 into 10 raised to power 6 volt upon, what is the second? 10 to the power 6 microsecond. So this is cancel out, and 1.5 volt per microsecond. 1.5 volt per microsecond, that is the value of the slew rate, guys. I think now this question is also clear to you. Yes, done. Yes, this type of mock test, na, maximum rate of change. Yes, that is the answer. Now, so we will arrange. Now, guys, this is the last question. Okay, so that is the last question from the analog. Then after that, Asu Jangra sir will join you. Okay. So stay tuned with us and like the session and subscribe our channel, because we are going to start very important session for you. First of all, YouTube plus app series. Then an operational amplifier has a time rate of change of voltage of 2 volt per microsecond. Again, that is the operational, has a time rate of, this is nothing but slew rate. If the peak output voltage is 12 volt, what is the bandwidth of the amplifier? Means on the same year, 2 questions from the slew rate. Okay. So already I have given the slew rate in case of operational amplifier. It is given by, or simply I am giving you the direct formula, maximum frequency of operation. That is 2 pi FM. This is in radian per second, and that is the 2 pi FM. It is given by slew rate divided by closed loop gain into what? VM. This is the standard formula, where VM is the amplitude of the peak amplitude of the voltage, input voltage. So what is the peak amplitude of the voltage is given? 12 volt. But it is the output voltage it is given. Or this is the input voltage. So it is multiplied with the gain, and that's why this complete will become amplitude of what? Output voltage. Amplitude of output voltage. So now, if this is the amplitude of the output voltage, so what is the FM? It is, because it is in asked in what? Hertz. Slew rate divided by amplitude of the output voltage. This is the ACL into VM into what? 2 pi. Now, what is the slew rate? Always change the unit of the slew rate. It will become 2 into 10 to the power 6 volt per second. Then divided by what? ACL. Not required, because ACL into VM will become the output of the amplitude of the output voltage 12 volt into 2 pi. This 2 is cancelled, and this will become 1 by 12 pi into 10 to the power 6 hertz. That is the frequency, maximum frequency of operation. And what should be the operational frequency? It should be always less than or equal to FM to get the distortion less output. And that's why it is in hertz. So 1 by 12 pi kilohertz, megahertz. 1 by 12 pi megahertz means answer is what? A, guys. So this is all about what network and what analog. Now,
okay guys, so I think it's time to start the session. So let's start with the first question. So this is the first question on your screen. Now tell me which option is correct. Do it fast, everyone. Do it fast. Let's see which option is correct. Let's see how many of you can tell the correct answer. It's very easy question. It's very easy question. Do it fast. Which of the following represent a stable system? Okay, stable system. He's asking about stable system. Impulse response of the system increases exponentially. No. Okay, because if the impulse response is increasing exponentially, its area will be infinite. Okay, and it will not be stable. For stability, mode of ht dt from minus infinity to infinity, it has to be finite. Okay, it has to be finite. So if function is increasing exponentially, area will become infinite, so it cannot be stable. Now, area within the impulse response is infinite. No, it should be finite. The roots of the characteristic equation of the system are real and negative. The roots of the characteristic equation should be negative. That's important. Real is not important. Okay. For a stable system, the roots of the characteristic equation of the system are real and negative. Real are not necessary, but the real part has to be negative. Okay. So, I mean, the most appropriate answer is Calcutta. Okay. The most appropriate answer is Calcutta. So roots of the characteristic equation has to be on the left half of the S-plane. Then only the system will be stable. If the roots are real and negative, then system will be stable. No problem at all. Okay. Now let's come to the next question, guys. Let's come to the next question. The next question on your screen is, of the following transfer function of second order LTI system, The underdamped system is represented by which of the following system is an underdamped system? Tell me guys. How to check whether the system is underdamped or overdamped? Tell me everyone. Do it fast. Do it fast. How to check whether the system is underdamped or overdamped? Tell me. You can check it using roots of the equation. If the roots are complex, and the real part is negative, we call it underdamped system. If the roots are complex, it means b square minus 4ac. If b square minus 4ac is less than 0, the system will be underdamped. Now in this question you can see that b square minus 4ac is 0, so this is critically damped. Here b square minus 4ac is greater than 0, overdamped. Here b square minus 4ac is again positive. But here in this question you can see that b square minus 4ac, okay, so it is negative, you can see that, okay. So answer is Delhi. I hope it is clear. Let's come to the next question guys. The next question on your screen is, okay, which of the following measures cannot be effective in reducing the noise? In reducing the noise, which cannot be effective, okay? So it's a learning based question. If you increase the channel bandwidth, if channel bandwidth is increased, noise cannot be reduced because noise has higher frequency. If the bandwidth is increased, then the noise will also get passed, and you cannot decrease the noise. You cannot reduce the noise, okay? So this will not help you. That's why answer is Calcutta. Let's come to the next question. The next question on your screen is, for the given relation, so this is some relation, P is some constant, P is a constant, the value of dy by dx at 0, 0. So we need to calculate dy by dx at origin. Now how to calculate dy by dx? P is some constant, so P, you can take P as 1, no problem, because P is a random constant. So you can assume P as 1. What's the problem? So if I take P as 1, then this will be root of 1 minus x square plus root of 1 minus y square is equal to x minus y. Now I need to take the derivative with respect to x. On both sides I need to take the derivative with respect to x. If you take the derivative of this term, it will be 1 by 2 root of 1 minus x square into minus 2x, okay. So this is the derivative with respect to x. You can see that the derivative is 1 by 2 root of 1 minus x square and minus 2x. Now what is the derivative of this term? This will be 1 by 2 root of 1 minus y square, and here you have minus 2y dy by dx, okay. This is the derivative here. That is equal to 1 minus dy by dx, okay. So I hope you get the idea how to calculate the derivative. Now in this derivative you can put x equal to 0 and y equal to 0. If I put x equal to 0 and y equal to 0, this is gone because x equal to 0. At x equal to 0 numerator is 0, at y equal to 0 numerator is 0. So this side will become 0. It means dy by dx at origin will be equal to 1. Dy by dx at origin equal to 1, okay. Now you can assume P as 2, there is no problem. I mean, many students will say, sir, why you are assuming P as 1? P is random constant, okay. So you can assume P as 2 or 3 or 4 or 5, whatever, okay. You'll always get dy by dx equal to 1. So answer is Calcutta, okay. Let's come to the next question guys. The next question on your screen is, we need to integrate this. We need to calculate this value. The integration, what is this value? So how to integrate it? You know that this limit is x square. It means if you put this limit, obviously this entire function will be in terms of x. It means we have to first take the derivative with respect to y, so that the dx term stay there, okay. So you have to assume that this limit is limit of y. These are the limit of y, okay, limit of y. We have to take these as the limit of y. It means we have to integrate with respect to y first. Why? Because if you are integrating with respect to y and you are assuming that these are the limits for y, then after solving this integration with respect to y, you will get the entire function in x terms, because the limits are in x, and the dx term is also there. So in the second stage, you can take integration with respect to x. I hope you got the idea. So first we will take the integration with respect to y. So if you are taking the integration with respect to y, it will become x square y. It will become y to the power 3 upon 3. Okay. And you can put the limit of y 0 to x square. These are the limit of y. Whatever this function is into dx and integrate from 0 to 1. So if I put the limit, upper limit minus lower limit, so you'll get a function like this. From 0 to 1, at upper limit it will become x to the power 4 plus x to the power 6 upon 3. This is the upper limit minus lower limit. At lower limit it is 0. So this will be the function we have now. And you can see that dx is left behind, and this term is only for x. So now you can further integrate. So it will become x to the power 5 upon 5 plus x to the power 7 upon 21. Okay, and you can put the limit 0 to 1. So upper limit, at upper limit it will become 1 by 5 plus 1 by 21. Okay, so 1 by 5 plus 1 by 21. So LCM is 105. It will be 21 plus 5, 26 divided by 105. Okay, 26 divided by 105. Answer is Agra. So this question was again very simple. Ultimately, it's a double integration problem and you can solve easily if you know that you have to take these as the limit of y. Because if you are putting these limits, the entire function will be in terms of x. It means you have to take this dx. You have to use this dx at the later stage. That's why I'm integrating with respect to y. Okay, and this x square limit is the limit of y. Okay, let's come to the next. Open loop system represented by, this is the open loop system. Okay, now the open loop system represented by the transfer function is stable and minimum phase type. Stable and, okay, so you can see that he is asking about stability. But he is not saying that stability of the closed loop system is there or the stability of the open loop system is there. Obviously, he is not asking the stability of open loop system. He is asking about the stability of closed loop system. Why? Because open loop is visible to you. Open loop system is unstable and it's a non-minimum phase system. What about the closed loop system? So if you want to calculate the closed loop system, then the closed loop system transfer function will be equal to GS divided by 1 plus GSHS. 1 plus GSHS. Okay, so this is my closed loop transfer function, GS divided by 1 plus GSHS. So I have done it directly. Now if you simplify this, it will become s minus 1 divided by, it will become s square plus s minus 6 plus 2s. This should be plus 2s. Okay, so s square plus 2s minus 6 minus 1, so minus 7. Okay, so this is the closed loop transfer function. You can see that GS divided by 1 plus GSHS. Okay, HS is 1. Okay, so I have done this, and this is the closed loop transfer function. So you can see that the 0 is in the right half of the S plane. It means obviously the system is non-minimum. Now whether it is stable or unstable, how to check? You have to check the poles of this system, and the poles of this system are minus b plus minus root of b square minus 4ac divided by 2a. Here it should be minus 4ac, but c is also negative, so it will become plus here. So you can see that the roots are lying, if you calculate this, let me show you, b square minus 4, okay, this is correct. So it will become minus 1 plus minus 1 by 2 root of, tell me, what is this value? 32. This is 32, okay? So it will become minus 1 plus minus 2 root 2. So now you can see that, wait a minute, okay, this is correct. Now you can see that one pole will lie in the right half of the S plane, one pole will lie in the left half of the S plane. So it means the closed loop system is unstable and the system is minimum phase system. Okay, so it's a non-minimum phase system, excuse me, it's a non-minimum phase system and unstable. Okay, non-minimum phase system and unstable. Answer is Delhi. Okay, answer is Delhi. So this was a simple question. Let's come to the next question. What is the Laplace transform of this function? It's very easy peasy. Obviously it has to be ut along that. So ut is not given. So by default, we have to take ut. Okay, e to the power minus 5t cos of 4t ut. Let's take it like this. Then only you can take the Laplace transform. Otherwise, it's not possible. Okay. So what is the Laplace transform of this function? First, let's take the Laplace transform of this function. That is s divided by s square plus 16. Okay. Now it is multiplied with e to the power minus 5t. So there is a frequency shifting property. S can be replaced with s plus 5. Okay. So answer is s plus 5 divided by s plus 5 whole square plus 16. Answer is Delhi. Okay. So this was again very simple question. Let's come to the next question, guys. So on your screen, the characteristic equation of a 3 by 3 matrix P is defined as, so this is the characteristic equation, and here it is here it is 1. Okay. Now what is asked is, here it should be, okay, it's fine. I denotes the identity matrix, then the inverse of P. We need to calculate P inverse. We need to calculate P inverse. So it's very easy question, guys. Wait a minute. Okay, so I need to calculate P inverse. Now how to calculate? The characteristic equation for the P matrix is this. Now we know that this P matrix has to satisfy this characteristic equation. It has to satisfy this characteristic equation, Cayley-Hamilton theorem. Okay. So now if I put this P in place of this lambda, it will become P cube plus P square plus 2P plus identity equal to 0. So in place of this eigenvalue lambda, I have put this P matrix. So the P matrix will also satisfy the characteristic equation. So you'll get this. Now I need to calculate P inverse. How to calculate P inverse? On both sides, you multiply with P inverse. If you multiply P inverse on both sides, then it will become P square. It will become P. It will become 2 identity. And it will become P inverse. On both sides, I am multiplying with P inverse. On both sides, I am multiplying with P inverse on this. So I will get this equation. Now from here, you can calculate P inverse. So P inverse will be equal to minus of this factor, minus of this function. Okay, and the answer is, I think, Delhi. Answer is Delhi. So this was again a very simple question. You can easily solve this. I hope it is clear. Let's come to the next question. A function yt satisfies the differential equation. So this is the differential equation. It is provided to us. Delta t is the unit impulse function and ut is the unit step function. Assuming 0 initial condition, what is yt? So we need to calculate yt. And there is no initial conditions. So you can use Laplace transform. Okay. If you take Laplace transform on both sides, it will become sys minus y0 plus ys equal to 1. Okay. I have taken the Laplace transform on both sides. Now initial condition is 0, so you can put it 0. Take this ys common. If I take this ys common, I will get s plus 1 equal to 1. So ys will be equal to 1 over s plus 1. Okay. 1 over s plus 1. Now you can take Laplace inverse. So tell me what is yt. So yt will be equal to e to the power minus t ut. E to the power minus t ut. Okay. Answer is Delhi. E to the power minus t ut. Answer is Delhi. Okay. So this was again a very simple question and you can easily solve this. Let's come to the next question. The next question on your screen is, a triangle is defined by, so actually we have triangle at the 3 points of the triangle are provided to us. What is the area of the triangle? How to calculate the area of the triangle? So there is A point, there is B point and there is C point. How to calculate the area of the triangle? What we can do is we can find two vectors, AB and AC, let's say. This is AB vector, this is AC vector. Now the area of the triangle is 1 by 2 AB cross AC and magnitude of that. Okay. This is the area. This is the area. This way you can calculate the area. In a triangle, if you know these two sides, you can take the cross product of these two vectors. Okay. And take the magnitude of those two vectors, divided by 1 by 2 is the area of the triangle. So now what is AB? This is B point, this is A point. So AB will be equal to the position vector B minus position vector A. So it will be minus 2 I cap. You can see that 0 minus 2, that is minus 2 I cap, 2 minus of minus 5 plus 7 j cap, 4 minus 1 3 k cap. Okay, so this is my AB vector. This is my AB vector. Now what is AC vector? What is AC vector? So AC vector is 0 minus 2, that is minus 2 I cap, 3 minus of minus 5, that is 8 j cap, minus 1, that is 0 k cap. Okay, so we found AC vector, we found AB vector. Now I need to take the cross product. So to take the cross product, what you need to do is you can write it like this: minus 273 and this is minus 280. Okay, this will be the cross product. So let's calculate this. So component of I cap is, tell me, 7 into 0 minus 24, minus j cap. What is the component of j cap? This into this minus this into this, so it will become 6 plus k cap. What is the component of k cap? Minus 16 plus 14, that is minus 2. Okay, so this is the cross product. Now I have to take the determinant of that and divide by 1 by 2. So 1 by 2 and determinant of this function is 24 square plus 6 square plus 2 square. Okay, and you can calculate this value. This is the area of the triangle. This is the area of the triangle. I hope it is clear. So let me tell you, it will be approximately 16 point. This should be the correct answer. Why it should be the correct answer? Why these answers are not correct? I have not calculated, but we know that the root is greater than 24, that's for sure. It means this value has to be greater than 12. This value has to be greater than 12. So greater than 12 is 16.112 is more likely. Okay, but it can be B also. You have to check. You have to check. I'm not pretty sure. Either B is correct or C is correct. Please check it. Okay, because it has to be greater than 12. So greater than 12, it can be this value or this value. Okay, so you have to check it, guys. You have to check it. Please check it. I don't have calculator, so you can calculate this value and you can check it. Okay, so either B or either C. So please, out of these two options, the option is correct. So please calculate this. Let's come to the next question. The next question is, which of the following power semiconductor device has the highest switching speed? Obviously MOSFET. MOSFET has the highest switching speed in power electronics. You must have studied this. Okay, let's come to the next question. If the unit step response, so UT, because of the UT, the response, the output is 1 minus e to the power minus alpha t UT. It must be UT here. Okay, it must be UT along with that. 1 minus e to the power minus alpha t UT. Now what is the impulse response? How to calculate impulse response? Calculate the transfer function. Transfer function is output Laplace divided by input Laplace. Okay, so what is output Laplace? Output Laplace is 1 by s minus 1 upon s plus alpha. This is the Laplace transform of output. Divide by the Laplace transform of input is 1 by s. Okay, now what is this value? It will be, you can see that s into s plus alpha. In numerator you must have alpha. Okay, I have solved this. So in the denominator you have s into s plus alpha, in numerator you have alpha into s by 1. This will become s by 1, s is cancelled, so you'll get alpha divided by s plus alpha. Okay, this is my TS. Now if you know the transfer function, the impulse response is Laplace inverse of this. So the Laplace inverse of this, alpha into e to the power minus alpha t ut. This is the Laplace inverse of this function. Okay, and it will be my impulse response. So the answer is Agra. Okay, so it's a simple question. This is a simple question. I hope you got this point. Let's come to the next question, guys. The next question is, what is the Laplace transform of the function delta t minus 2? So it's again very easy. Delta t has Laplace transform as 1. So delta t minus 2 has Laplace transform of 1 into e to the power minus 2s. Okay, so the answer is Calcutta. Answer is Calcutta. This was easy peasy. Okay, let's come to the next question, guys. What is the range of k for which the unity feedback closed loop system with open loop gain, this will be stable? For what value of k the open loop system is stable always? Okay, and it is not mentioned about a, so let's take a as positive number. Let's take a as positive. For what value of k, for what range of k, this closed loop system, the open loop system is given, and we want the range of k for which the closed loop system is stable. So you can take the help of root locus, because ZSHS is provided to you. Okay, wait a minute. What is the range of K for which the unity feedback closed loop system with open loop gain will be unstable? We want unstable range. Okay, so if I draw its root locus, there are 3 poles. No? 2 poles are lying here, 1 pole is lying here at minus A position. Okay, I'm assuming that A is positive. You can take A as negative, then also no problem with that. Okay, so these are the pole location. Now if you draw the root locus, if you increase the value of K, so for K equal to 0, the closed loop pole will lie at this position. If you increase the value of K, this pole will go on this side and these 2 poles will go on this side. Okay, it means the system will always be unstable. For K equal to 0, it is unstable, and if you increase the value of K, again these 2 poles will go on this side. It means the system will always be unstable. So you can take K from, K should be greater than 0. Okay, K should be greater than 0. Excuse me, K should be greater than 0. But wait a minute. So answer should be Bombay. Answer should be Bombay. But wait a minute. Wait a minute. Why? Because you are looking only at the positive side. You are looking only at the positive side. Let's take about the negative side also. If K is negative, what will happen? If K is negative, then what will be the root locus? The root locus will be, what will be the root locus if K is negative? Let's say the 2 poles are here, and so if K is negative, this will be the part of root locus. This will be the part of root locus. Okay, this will be the part of root locus. Now if this is the part of root locus, and this will be the part of root locus, and this will be the part of root locus. Okay, this will be the part of root locus, this will be the part of root locus. It means what will happen? 1 pole will go on this side, 1 pole will go on this side, and 1 pole will go on this side. It means 1 pole will always remain on this side. If K is negative, you have to plot counter root locus. So you can see that this will be the part of root locus and this side will be the part of root locus. It means out of these 2 poles, 1 pole will always go on this side. If you are taking K as negative, it means from 0 to minus infinity you are going. Then this will be the part of, it means 1 pole will always be on the right half of the S-plane if K is negative, and if K is positive, then also 2 pole will be on the right half of the S-plane. It means system will always be unstable, whether you take K from minus infinity to 0 or 0 to infinity. So that's why D is correct answer. Okay, D is the correct answer. I hope it is clear. I hope it is clear. Okay, why not B? Because B is telling you only about the positive side, and you have to look at the negative side as well. Okay, so that's why. Let's come to the next question. So in this question, I need to calculate this integration, but I think there is a correction in this question. Let me check the original question, guys. Let me check the original question, because there is a correction in this question. Let me see the original question. Let me see the original question, because this question, I think something is missing here, and actually I told the typist also that please correct this question. So wait a minute, let me see the original statement of the question. Just give me 1 minute, guys. Just give me 1 minute. I'm just checking it. Wait a minute. Okay. Almost there. Yes, cos tau. It is a sine of t minus tau into cos tau. Okay, d tau. This is the question from 0 to 2 pi, and it is 1 over 2 pi. This value is asked. What is this value? So now in this question, how to solve this question, guys? I mean, try to apply some trick. And what should be the trick? Look, the trick is very simple. Let's put t equal to 0. Let's see at t equal to 0, what is this value? If you put t equal to 0, then you can see that this function will become 1 by 2 pi, 0 to 2 pi, the sine of tau, sine of minus tau, take this minus out, into cos of tau d tau. Okay, you can divide with 2 and multiply with 2. So if you divide and multiply with 2, it will become 1 upon 4 pi integration 0 to 2 pi, and this is sine of 2 tau d tau. Okay, it will become like this. If you multiply by 2 and divide by 2, you'll get this. And if you integrate this, you'll get 0 answer. It means at t equal to 0, this answer has to be 0. Now, in which option it is satisfying? At t equal to 0, this is 0. This is already 0. This is already 0. This is also this is not 0. So one option is eliminated. Now take t as pi by 2. At pi by 2. Let's see at t equal to pi by 2. If you take t as pi by 2, it will become 1 upon 2 pi integration 0 to 2 pi sine of pi by 2 minus tau, that is cos tau. So you become cos tau into cos tau, that is cos square tau d tau. And it will become 1 upon 2 pi integration 0 to 2 pi cos square. What is cos square? Cos square is 1 plus cos of 2 tau divided by 2. Okay, divide by 2 into d tau. Now you can easily see that if you integrate this for 1 by, first let's integrate this 1 by 2. So you'll get 1 upon 2 pi. The integration of this 1 by 2 is 1 by 2 into 2 pi. And the integration of this cos 2 tau is 0. Okay. Now the answer is 1 by 2. It means at t equal to pi by 2, the answer has to be half. So in which option it is satisfying? At t equal to pi by 2, this is 0. This is 0 always. At t equal to pi by 2, it is half. That's why answer is Delhi. It means you don't need to solve this question entirely. If options are provided, you can check, you can take any particular value of t and solve the question and check which option is satisfying the answer. Okay, so this is the simple trick. You can apply this trick, guys. It's important and you'll get the answer at very fast pace. Sir, what are the allied topics in electrical engineering branch and how to prepare those topics? Okay, allied topics means the core subject are the main subject and the allied subject to the core subjects are network, signal, control, analog. Okay, those topics which are used in these three core subjects: machines, power system, power electronics. Okay, so these topics are the core allied topics, you can say. So let me tell you, the allied topics are network, signal, control, analog. These are the allied topics of core subjects. Okay, digital is not allied topic. Digital you can skip. Okay, digital is not the allied topic. So let's come to the next question, guys. So this question was very easy and you can take the advantage of t. You can put the value of t and you can solve this question. Let's come to the next question. The next question on your screen is, you can see ut and rt denote the unit step and the unit rep function respectively. Ut convolution rt is their convolution. Okay, we already know that. Now then the function u of t plus 1 convolution r of t minus 1 is. We need to check what is the value of this function. Which option is correct for this convolution? So it's very easy. You can use the Laplace transform, no? So the Laplace transform of this function is e to the power s divided by s multiply by 1 by s square e to the power minus 2s. Now you will get e to the power minus s divided by s cube. So this is the Laplace of this function. Now I need to take inverse Laplace of this function. Just not look at this function e to the power minus s. I will take this, I will think about it later. So first I have to take the inverse of 1 upon s cube. What is the inverse of 1 upon s cube? Tell me, guys. It should be half t square ut. Half t square ut. Okay? Because we know that t raised to the power n ut, the Laplace transform of this function is n factorial divided by s to the power n plus 1. So if I take t square ut, then the Laplace transform will be 2 divided by 2 factorial. 2 factorial is 2 divided by s cube. Now you can take this 2 in the denominator. Okay, so 1 by s cube will be will be present here, and the inverse Laplace is 1 by 2 t square ut. Okay, so for 1 by s cube, this is the inverse Laplace, but I have to multiply here with e to the power minus s. It means in time domain you have to replace t with t minus 1. So the answer is 1 by 2 t minus 1 square u of t minus 1. Okay, this is the correct answer. Now you can see that this is none of the above. Okay, answer is Delhi, because u is not there. It should be u here. I think there is a typing mistake. It should be u here. Okay, it should be u here. Okay, if u is there, if u is in between the, if u is there, then option C is correct. I think this is the typing mistake. Okay, but if u is not present, then option D is correct. So please check the options carefully. Okay, I think there is a typing mistake here. It should be u. So 1 by 2 t minus 1 square u of t minus 1. This should be the correct answer. Okay, but if u is not there, then the D answer is correct. None of these. Okay, let's come to the next. So the next question on your screen is, consider function fx is equal to x square minus 4 whole square. X is a real number, then the function has maxima and minima. He's asking about maxima and minima. How many minimas and how many maximas are there? So what you can do is, you can take the derivative. So the first derivative is this. And you know that this first derivative will be 0 at x equal to plus 2, minus 2, 0. So there are 3 points. There are 3 points at which either maxima will lie or minima will lie. Okay, 0, plus 2 and minus 2. So what we can do is we can take the second derivative. Okay, the second derivative of fx is equal to, what is the second derivative of this function? It will be 4 into x square minus 4 plus 4x into 2x. Okay, so this is the second derivative, guys. So let me simplify it. It will become 4x square plus 8x square, that is 12x square minus 16. Okay, it will be 8x square here and 4x square, so 12x square minus 16. Now let's see, at x equal to 0, at x equal to 0 it is negative. The double derivative is negative. It means at x equal to 0 you have maxima, because the double derivative is negative. So you have maxima. At x equal to 2, at x equal to 2, you can see that it is positive. So you have minima. And x equal to minus 2, again positive. This is again positive. So minima. So it has 2 minima and 1 maxima. Okay. So 2 minima. It has only 2 minima. Okay. 2 minima. And 1 maxima. But 1 maxima option is not there. Only minima option is asked. So only 2 minima is there. I hope it is clear. Let's come to the next question. Let's come to the next question, guys. Now in this question you can see A is n cross n matrix with m greater than n and I is the identity matrix. It is given that A1 is equal to this. Now if I simplify this, it will become A inverse into A transpose inverse into A transpose. Now you can see that this is A transpose inverse and this is A transpose, so they will cancel. So A1 will be equal to A inverse directly. Okay, so from this relation you can see that A1 is equal to A inverse. Now which statement is correct? Look at which statement is false. Which statement is false? Look at the first statement. In the first statement, A into A1 can be replaced with A inverse into A. Now it will cancel and you will get A only. So this is the correct statement. Okay, this is the correct, it's not false statement, so it is the correct statement. Now let's come to B, statement B. In statement B, A into this A1 is A inverse and take the square of that. So it has to be identity. Okay, so this side is identity. What about this side? This side is also identity. Why? Because this is A inverse. So again identity. So this is also true. Look at this. A into A1 is identity. This is also true. What about this? Now, if you put A1 here, if this is true, this cannot be true. So answer is Delhi. Because Delhi is the false statement. Because we have already seen that A into A1 into A. It must be equal to A. It not be equal to A inverse. Okay. This is A inverse, na? So we have already checked that this must be equal to A. It cannot be equal to A inverse. That's why D is the false statement. Answer is Delhi. Let's come to the next question, and this is the last question, guys. So let me contact Naveen Golapalli sir, because from this point onward Naveen sir will continue. Okay, so let me message Naveen sir so that he can connect with you. Wait a minute, guys. Okay, Naveen sir is in the chat section. Okay, guys. So let's first cover this. Let's cover this last question. So I have this last question, guys. And in this question, consider parallel RLC having an inductance of 10 millihenry, capacitance of 100 microfarad. Determine the value of the resistance that would lead to critically damped response. So we want the value of R for which the circuit become critically damped. Okay, and it's a parallel RLC circuit. Parallel RLC circuit. Now, if this is the circuit RLC, we want critically damped circuit. Let's assume that there is a current source here. Okay. Now, what I want to do is I want to calculate this capacitor voltage VCT. Let's take this current as the input and VCT as the output. And let's write this in Laplace domain. So if you are writing this in Laplace domain, it will be R, here it will be Ls, here it will be 1 by Cs. Okay. Now, if you don't remember the formula, because I don't remember the formula for what value of R the system is critically damped. That's why I'm telling you how to approach the problem. So what you can do is, this is the current source. So current source can be replaced with I naught by S in Laplace domain. Okay. Now what I want to do is, I want to take this voltage. I want to calculate this voltage, and I'm assuming that this voltage is the output voltage. This voltage is the output voltage. Or you can say these are in parallel, no? So this voltage is same as this voltage, same as this voltage. So you can calculate the voltage across any element. Let's take that voltage as the output voltage. So what is the transfer function of this system? Can you calculate? The output voltage divided by the input. Input is current source. Okay. So how to calculate the voltage? It's very simple. Let's take the parallel of these elements. So if I take the parallel of these elements, it will be 1 over R plus 1 over Ls plus Cs. Okay, this is the parallel equivalent. This is the entire impedance. Okay, let's simplify this. So it will be RLS. RLS. This is the LCM RLS that will go in the numerator. Okay, and here you're left with RLCS square plus R plus LS. Okay, so I have taken the LCM as RLS. Now that RLS will go in the numerator, and in the denominator you have RLCS square plus it will become R here and it will become LS here. Okay, I hope it is clear. So what I'm doing is I am calculating the impedance of this. Since they are in parallel, so 1 divided by 1 over this impedance plus 1 over this impedance plus 1 over this. Now you can see that now I can take this RLC common, so it will become RLS divided by, if you take RLC common, it will become S square plus 1 by RCS plus 1 by RLC. Okay. Okay, wait a minute. 1 by LC. It has to be 1 by LC. Okay. Now this is my impedance. Wait a minute. So this is my impedance, guys. So we have calculated the impedance of this entire network. Whatever the impedance is, multiply by I naught by S. That is my VS output. Okay. Or you can say that this current, let's not take it I naught by S, let's take it as a function IS. Let's not take it as a constant current source. Let's take it as a function IS. This is my input function and this is my output function. So if you take this IS in the denominator, you will get the transfer function. So this is the transfer function, guys. Now, if you want the system to be critically damped, then the roots of this equation has to be equal. It means the discriminant of this quadratic function has to be 0. And how to calculate discriminant? It's b square minus 4ac. So b square, this is my b, so 1 over rc square. B square minus 4ac. A is 1 and c is 1 by lc. It has to be 0. Okay. Now from here you can see that 4 upon lc is equal to 1 by rc square. Okay. Now from here you can see that RC whole square is equal to LC by 4. Is it clear, everyone? You can see that. Okay. Now you can take this C square. So it will become, from here you can say that R square equal to, from here it will be R square is equal to L by 4C. Okay. Now what is R? R is equal to 1 by 2 root LC. So R is equal to 1 by 2 root LC. 1 by 2. Okay, let me write it here. So R is equal to 1 by 2 root LC for the system to be critically damped. This is the condition for critically damped system. R has to be 1 by 2 root LC. Now you should remember the method, because sometimes the formula, you can forget the formula. It's a parallel RLC circuit. So what I can do is, I can assume that this output, this voltage is the output and this current is input. So I am taking this current as IS. I'm not taking this as I naught by S, because this, I'm not assuming that this current is constant. Let's assume that this current is a function IT. So the Laplace of IT is IS, and I need to calculate this voltage. How to calculate voltage? First you can calculate the impedance. How to calculate impedance? These are in parallel. So you can take their parallel equivalent. This is the entire impedance. You can take this RLC common. So this is the impedance. You can also, you can even cancel this now. Okay. So this is my impedance. Ultimately I have to look at the quadratic function. Impedance into IS is the VS. So the transfer function is VS upon IS, output by input. Okay. So this is the transfer function. Now in this transfer function, if this second order system is critically damped, it means the roots of this equation has to be equal. It means the B square minus 4AC has to be 0. So what I did is, this is B, so B square minus 4AC. Okay. This is C, A is 1. So B square minus 4AC is equal to 0, and I have calculated the value of R. R is 1 by 2 root LC. Now, if you put the value 1 by 2 root of L, L, what is the value of L? L is 10 millihenry. And what is the value of C? C is 100 microfarad. Okay, so now you can see that if this 10 to the power minus 3 will go in the numerator, it will become 10 to the power plus 6. Multiply by 10 to the power minus 3, so it will become 10 to the power plus 3. And into 10, it will become 10 to the power 4, divided by 10 to the power 2. So now it will become 1 by 2 into root 100. That is 10 by 2. 10 by 2 is 5. Answer is Agra. Okay, answer is Agra. I hope it is clear. So this question was very good question. If you don't remember any formula, then you should approach like this. If you remember the formula, then you can directly calculate the answer. Okay. So here I rest my case, because I have solved all these questions of maths, signal and control. Okay. And I hope you enjoyed this session. Don't forget to subscribe our channel, and don't forget to like this session. So now from this point onward, Naveen Golapalli sir will continue for the core subjects of electrical engineering, like machines and power system. Okay. So I welcome Naveen sir, and you can continue from with Naveen sir. Okay. So let me stop the session and you can continue with sir. Thank you.
Hi, hello. Good afternoon everyone. Can you confirm about audio? Can anybody confirm about audio? Audio is clear. Hi Ashok. Welcome to the session. Can anybody confirm about audio, so that I'll switch on the video also? All right. Come on guys, please do let me know about audio. And okay, right, clear. Chalo. So I think Ashu sir has taken the subject, some questions from signals, controls, power electronics, and some questions from electric circuits also as well, it seems. Okay, fine. So in this session I am going to cover some questions on power system. Along with the power system, I'll take up some questions on machines as well as measurements. So I have around 14 or 15 questions around I have in these three subjects. measurements will be around 3 questions. Machines are around 6 plus power system around 5 to 6 questions. So altogether it will be around 15 or 16 odd questions. We will be discussing those questions from these 3 subjects. Okay. After my session, Saket sir will join. Right. So please have a look at this question. Let me hide myself so that you can see the complete question. Yeah, I'll increase my voice. Just give me a moment. Is it clear now? Louder? Is it clear now? Ashok? Okay. Right. So have a look at this question. The question is, he has given about a load center of 120 megawatts derives power from 2 power stations connected by 220 kV transmission lines of 25 kilometers and 75 kilometers as shown in figure. Figure is missed. Figure missed here. So I have an idea about the figure. Let me show you the figure also. So I have generator here, and this is going to be around 25 kilometers distance, and another line distance is going to be around 75 kilometers. So this side also we will be having a generator, one more generator, and this side also we will be having another generator. So this is how the generator and load connection will be. The load is going to be located at this point. So this is of 120 megawatts. Right. The 3 generators G1, G2, G3 are of 100 megawatts. So the power rating of each generator is going to be 100 megawatts. And each have identical fuel cost characteristics. Same incremental fuel cost characteristics are same, he is saying. So the minimum loss generation scheduled for supplying 120 megawatts load. So simple logic, general, what I can say is general, you can apply general idea. The total load on the generators will be 120 megawatts, and each generator is capable to generate up to 100 megawatts. To generate 100 megawatts, each generator will consume the same amount of fuel. The fuel cost characteristics are same. So when the fuel cost characteristics are same, obviously I'll try to share more load on the generator 1 because the distance of transmission line is less, and hence the transmission line loss is going to be very less. Here the distance of transmission line is more, therefore the transmission loss is definitely more than the first case. PL1, PL2, so PL1 is absolutely less than PL2. So we choose obviously the best possible way. Okay, minimal losses. He said that minimum loss generation schedule. So try to keep more load on the generator 1, and rest of the load can be shared between these generator 2 and generator 3. Okay. So you can, if let us take up 100 megawatts. If you keep 100 megawatts on the generator 1, and the rest of 20 megawatts has to be scheduled on 10 and 10 on the generator 2 and generator 3. That's the only possibility, right? Okay, remaining 20 megawatts has to be scheduled on generator 2 and generator 3. All right. Now, if you look at the options are not with 100 and 10 and 10. So what is the best way? You have to go with the best possible answer. So best possible answer is A. If you are going to place 90 megawatts on generator 1, 90 megawatts load sharing by the generator 1, remaining 30 megawatts share has to be done by generator 2 and generator 3, 15. Why it is equally sharing? Because the distance of transmission line is 75 kilometers for both the generators, and the fuel cost characteristics also same. So you cannot place simply 30 megawatts on single generator because this is also operating, no? So for economical load division, you have to divide the load properly. So the best option is A. Very good, Ashok. Let us move on to the next question. If anybody has doubt at any point, you can ask me. If anybody has doubt at any point, you can ask me. All right. Look at this question. This question is given about natural frequency of oscillations. The question is, a 3-phase 50 Hz synchronous generator is connected to an infinite bus. The maximum power that can be transferred to infinite bus is 1 per unit. The mechanical input to the generator is 0.866 per unit. The inertia constant of the generator is 5. Find the natural frequency of oscillation of the generator of the system. So natural frequency of oscillation, there is a direct formula. I think from the power curve you can take up. So this is going to be the electrical power, and I can also represent the steam power curve also. So this is going to be load angle. So the power curve is going to be like this. This is going to be generally the electrical power generated by the synchronous generator. You can also draw the steam input or otherwise mechanical input which you are going to apply. If this is going to be the steam input line or mechanical input line, this is where the steam input and electrical output both are going to be equal. That is the equilibrium point, I can say. And at this point at this load angle, the generator is going to operate. Okay, right. What he is asking? He is asking natural frequency of oscillations. So for the natural frequency of oscillations, the formula, if you know, it is going to be synchronizing power into the omega divided by 2h, of course root over. How do you calculate synchronizing power? The synchronizing power can be calculated from differentiation of the electrical power with respect to delta. What is electrical power equation? EV by XS into sine delta, no? EV by XS into sine delta, right? So in the same way, if you differentiate and if you do that one, you will get it as EV by XS into sine delta. That EV by XS only we call it as maximum power transferred by the system. Why? Because generally electrical power is going to be EV by XS into sine delta. When will you get this power as maximum? When this delta is 90 degrees. When the load angle is 90 degrees, you will get maximum power. So if sine delta, sine 90, then it will become 1, then 1 into EV by XS. That will be maximum power. Na? So instead of writing EV by XS into sine delta, I am writing P max into sine delta. That is also fine, no issues. Why I am writing in terms of P max? Because he has given the maximum power that can be transferred to the infinite bus. That's the reason why I am representing in terms of maximum power. So I have got it as 1 into sine delta. So if you know did he mention anything about synchronizing power? He did not mention anything about synchronizing power. He mentioned about maximum power and he mentioned about the steam input also. So at the equilibrium point, I can equate the steam input or the mechanical input and electrical output. The steam input he has mentioned it as root 3 by 2, that is 0.866, and electrical power is going to be P max into sine delta, I can write, or EV by XS into sine delta. This is anyhow it is going to be 1. So sine delta I am getting it as 0.866. So from this I can get delta as sine inverse of 0.86. It will be around 60 degrees. Sine 30 will be 0.5, sine 60 will be 0.866. Okay, so is it visible? Just give me a moment. Let me hide my video. Okay, so this I'm so sorry for the delay. So this is my load angle I'm going to get. So if you substitute, then it will be sine 60. So I missed somewhere. Delta. delta we got now. Oh, synchronizing power, na? This is synchronizing power. Differentiate the, this will be actually cos delta, no? Synchronizing power. Somewhere I missed. Synchronizing power graph will be like this, so it will be cos delta function. So if you differentiate this one, I'm sorry, cos delta. Yes or no? Cos delta. Magnetic coupling factor. Cos delta. So cos 60. So if you substitute cos 60, how much? It will be 0.5. Synchronizing power will be 0.5. So substitute all these values here, you will get the answer. Can you tell me, anybody, can anybody tell me the answer? Natural frequency of oscillations will be, synchronizing power is around 0.5. Omega, it will be 2 pi f, 50 Hz frequency divided by 2 into inertia constant is 5. How much this will be? 5 tens 5 to 2 root 5. Oh, root 5 pi. Root 5 pi radians per second. Is it clear for everyone? This is the answer. D is the answer. Okay. All right. So let us move on to the next question. A 3-phase 50 Hz synchronous generator is connected to an infinite bus through a transformer and 2 parallel transmission lines. The input mechanical power to the synchronous generator is 0.8 per unit. Grid is consuming a power of 0.8 plus j 0.4 per unit. The generator impedance is 0.25 per unit. Transformer impedance is 0.5 per unit. Each transmission line impedance is 0.5 per unit. If the infinite bus voltage is 1 per unit, then what is the generator voltage load angle? So delta is asking. Okay, so if you see this, it will be like this. You can have a generator, synchronous generator. The synchronous generator will be connected to transformer, and then a transmission line, 2 transmission lines, and then a load. So this is going to be a single line diagram or the simple diagram of a power system. So he has mentioned the reactance or impedances of each and every element in the power system network. So if I draw the equivalent reactance of those elements, it will be like this. Generator impedance is going to be around 0.25 per unit. Transformer impedance is going to be around 0.5 per unit. And 2 transmission line impedances are going to be 0.5 per unit. And this is where I have load. So the load is going to be consuming the power of 0.8 plus j 0.4 per unit. This is active power and reactive power. If it is not visible, let me hide my camera. So this is going to be your equivalent circuit or reactance diagram circuit. Okay. He is asking the generator voltage angle, this E at an angle delta. E at an angle delta is asking. Don't think that this is going to be E. He has given mechanical input. That is not the EMF generated by the generator. Be careful. Okay. He has mentioned that this bus voltage, infinite bus voltage is 1 at an angle 0. So we know this voltage, the voltage at this point is 1 at an angle 0. Okay. So if you simplify this network, 0.25 plus 0.5, 0.75, and this combination will be 0.25. So 0.25 plus 0.75, it will be 1. So E at an angle delta, and this is my V, and here is my load, 0.8 plus J 0.4. This is the reactive power consumption, this is the active power consumption. You can take up it as excess. It is same like, you know, power flow equation in the synchronous machine, the same thing. So if you remember the power flow equation in the synchronous machine, then it is very easy. So active power can be taken as EV by excess into sine delta. Reactive power will be given as EV by excess into cos delta minus V square by X. I know the active power consumption by the load, I know the reactive power consumption by the load. If the load is consuming this much active power and reactive power, who has to deliver? Obviously the generator has to deliver the same 0.8 per unit of active power, 0.4 per unit of reactive power. So substitute the values and you'll try to get some equations. If you substitute active power value, then this leads to 0.8 is equals to E value we do not know. V value I know that is 1. Excess value, synchronous reactance of, or you cannot say synchronous reactance, altogether it will be transformer reactance, line reactance and generator reactance, altogether it will be 1 per unit. And this equation comes out as E sine delta is equals to 0.8. This is one equation. And here Q is of 0.4 is equals to E into V divided by 1 into cos delta minus V square, that is 1 square by 1. So this is the equation you are going to get, second equation. Okay. So first equation is going to be around E sine delta is equals to 0.8. Second equation is equals to E cos delta minus 1. So if you send this minus 1 onto this side, it will be 1.4. So E cos delta is equals to 1.4. So it's like you can put it in a triangle and you can try to solve, you can try to get a delta value. Adjacent side hypotenuse, sorry, adjacent side is going to be of 1.4, opposite side is of going to be 0.8. Anyhow we need delta, no? So the delta will be tan inverse of 0.8 by 1.4. Tan inverse of 0.8 by 1.4. So this is the value. So 0.8, it is like 8 by 16 approximately. If you take up 1.4 as 1.6, you can take up it as 8 by 16. So 8 by 16 will be 1 by 2, 0.5. So tan inverse of 0.5, what is the rough value? Can you tell me? Tan inverse of 0.5. Just give me a second. I'll just come back. My daughter is calling me many times. Just give me a second. 1 minute. Within 1 minute, I'll come back. Please tell me the answer. Don't open the door, okay? Is it coming out as 26.86? Tan inverse of 0.5. $26.86, so 26.56. So nearby answer could be the proper answer. Otherwise, 0.8 by 1.4. Calculator is required little bit. 29. Oh, 0.8 by 1.4. It is coming out as 29.7. So 29.7. Then it will be 30. Could be the answer. So there is a small difference. Within small difference, we are going to get wrong answer. So 30 could be the proper answer. 29.74 I am getting. Around. So be careful with this one. I think this is little bit difficult only. If you do not remember, then gone case. If calculator is there, then you will get a correct answer. Okay. So let us take up next question. If the positive, negative and zero sequence reactance of an element of a power system are 0.3, 0.3 and 0.8 per unit respectively, then the element would be, what is the element? Positive sequence reactance, negative sequence reactance are same. Generally for transformer also it will be same. But zero sequence reactance is greater than positive sequence reactance and negative sequence reactance. So generally for synchronous generator, positive sequence reactance, negative sequence reactance will be little, sometimes it will be different, sometimes it will be same. For synchronous motor also. For static load, no, it is not like that. The only option is transmission line. There is one statement also. Generally, zero sequence reactance is around 2 to 3 times the positive sequence reactance. So 2 into 0.3 it will be around 0.6. 2 into 3 into 0.3 it will be around 0.6 to 0.9. Because the ground return is also going to be included. So the ground return, if you consider that one, and at different soil conditions, so the reactance is going to change, and hence it is taken as 2 to 3 times. So transmission line will be the proper answer. Very good, Ashok. What is the next question? The next question is about 100 megawatts power station delivers 100 megawatts for 2 hours, 50 megawatts for 6 hours in a day, and is shut down for maintenance for 45 days each year. So in an year, out of 365 days, 45 days it is going to be shut down. Calculate the annual load factor. So for this, if you want to solve this one, load factor formula you should remember. It is average load by maximum demand. Average load by maximum demand. Maximum demand into 365 days. And average load, how many days it is active? Active days. Out of 365 days, how many days it is active? Okay. So you need to solve for maximum demand. Anyhow, it is going to be 100. What is the average load? From the load curve you will get, okay, actually from the load curve you will get it. If first of all you should draw the load curve. If you draw the load curve, it will be like this: time duration and the load curve. He mentioned that 100 megawatts for 2 hours. 100 megawatts for 2 hours. And 50 megawatts for 6 hours. So let me take up it as 6 hours. 2 plus 6, 8. Okay. So this is the load curve you are going to get. So from the load curve you can pick the maximum demand. So you cannot directly take up the generator capacity here. From the load curve you can pick the maximum demand. To solve the average load, you can take up the area under this load curve. So what is the area under the load curve? You are going to get 100 into 2 plus 6 into 50 into 6. Only for 8 hours duration out of 24 hours duration. Okay. Rest of the time anyhow it is going to be shut down, right? So this is my average load. So substitute that value here and solve it. How many days it is going to be active? How many days it is going to be active? 45 days it is going to be shut down. So that means 365 minus 45 days. So it will be around 320 days it is active out of 365 days. This is the average load, active days over 365 days and divided by maximum demand. If you take up maximum demand as 100, so this could be the answer. Solve it, you will get the answer. 200, 300 divided by, if you take up approximately it is 25, 300 divided by 500 divided by 25. So 20 probably you will get 20. 20 divided by 100, you will get 5, 1 by 5, 0.2. Okay. 30, 30, 0.2, 32 by 35. Solve this one. Maybe is it coming out as 22 or 21? How much? So this value is leading to around 0.5 approximately. So 0.5 into 320 divided by 365. I am more habituated for calculator. How much it is coming out? 22.5. Is it so? Rough calculation, if I did 320 divided by 365 into 0.5. Did I miss any point? 200 plus 300. 300 divided by 24 divided by maximum demand. Let us not do this one. Into 320 divided by 365 into 100. Can anybody tell me? My calculator is giving wrong answers. Out of the options, it is giving out of the options. Can you tell me what is the answer? 500 divided by 24. Oh, 18.26 I am getting. 18.26 I am getting if you solve this one. Is it so? Ashok is saying 22.5. I am getting around 18.26. If you are going for approximate calculations, it is giving a wrong thing. This is I did in a separate manner. So solve it properly. First solve average load into this active days divided by 100 into 365. $320 divided by 365. Getting around 18.3. So please check this one. I think this is the formula, but check the answer. Okay. So those are some questions on electrical power system. So let us take up some questions on electrical machines. He has given a question about leakage flux lines. Assuming the leakage flux to be negligible when HV side of single phase 100 volts 50 hertz 100 by 50 volts 50 hertz transformer is connected to 50 volts 25 hertz AC source. The core flux of the transformer is, so it is actually rated for what? 100 by 50 high voltage and low voltage winding. This is actually rated for 100 by 50 hertz transformer. But what he is doing, he is connecting a source of 50 by 50 volts 25 hertz source. So the source voltage is going to be 50 volts 25 hertz. So it's like voltage to frequency ratio. In the first case it is 100 by 50, it is going to be 2. In the second case it is going to be 50 by 25, this is also going to be 2. So the voltage to frequency ratio is going to be constant. If the voltage to frequency ratio is going to be constant, then the flux density establishment is also going to be constant. That is what. So he is asking core flux establishment. Will it be same or different? It won't be half or twice or 4 times. It will be same only. Voltage to frequency ratio you need to check up. That's it. Yeah, right? Very good. If you look at this one, A 10 kVA 200 by 2000 volts transformer is feeding a load resistance of 2.5 per unit based on the rating of HV side. Okay. The actual value of the load resistance referred to LV side. So this is my low voltage side and this is my high voltage side. So we have 2.5 per unit. This is my load resistance. And of course the high voltage winding voltage is 2000. The rating of the transformer he has mentioned as around 10 kVA. What is asking? The actual value of load resistance referred to LV side. So first of all, calculate the actual value of this load resistance. If you remember the formula of per unit resistance or per unit reactance, actual value into VA rating divided by voltage square. So you substitute VA rating divided by voltage square, you will get the answer. I need actual value. So this is the actual value of load resistance. So I will get R per unit into V square divided by VA. What is the per unit resistance? He has given 2.5. What is the voltage? Operating voltage on this side, this is 2000. So please substitute 2000. 2 into 10 to the power of 3 into 2 into 10 to the power of 3. 2000 square, na? 2 kV volt square. It will be 4 mega. What is the VA rating of the transformer? 10 kVA. So let us substitute 10 kVA. Cancel out. So 2 5s. This comes out to be 5 into 0.5. So 5 is 25. So 5 into 0.5 will be 2.5. So 0.5 into 2, it comes out to be 1, na? 1. 1 into 10 to the power of 3. So 1000 ohms I am getting. So the actual resistance of the load is around 1000 ohms. Now I need to transfer, or what I need to do, the load resistance referred to LV side. So if I transfer this load resistance onto the LV side, what is the equivalent value is asking. Obviously low voltage winding will carry large current. If it is carrying large current, because in order to have magnetomotive force balance, if the voltage is low, current should be high. If the voltage is high, current should be low, right? So in this winding, current will be generally high. So ILV is generally greater than IHV. If current is greater, that means resistance of the low voltage winding is definitely less than resistance of the high voltage winding. On the high voltage side, the resistance is 1000 ohms. If you refer this resistance onto the low voltage side, definitely the answer should be less than 1000. Definitely answer should be less than 1000. So I can eliminate this C and D. So Ashok is saying 10 ohms. Others also can respond. What could be the correct answer? So when you transfer the load resistance onto the primary side, I can write it as RL dash will be RL by K square. RL is of 1000. What is K? Transformation ratio. What is the transformation ratio? N2 divided by N1 or V2 divided by V1 or I1 divided by I2. V2 is of 2000. V1 is of 200. So it will be 10. So K is of 10. So 10 square will be 100. So you will get it as 10 ohms. A is the answer. Very good, Ashok. Others also please respond. Since long time I am watching only one name. Now look at this question. While performing short circuit test on a single phase 110 by 220 volts 50 Hz transformer with LV short circuited, the wattmeter reading is found to be 20 watts. Okay. So the LV winding is short circuited. So if you want me to show you the ammeter, voltmeter and wattmeter, so you can take up this voltage as short circuit voltage. So the wattmeter reading he is telling it as 20 watts. If the same test is performed on the HV side, if the same test is performed on HV side, if the same test is performed on the transformer with HV shorted, So this is my high voltage winding and this is my low voltage winding. Here low voltage winding is short circuited. If I short the high voltage winding, what could be the wattmeter reading? He is asking. What will be the wattmeter reading? He is asking. Ammeter, and this is my voltmeter, and here is my short circuit voltage. If HV is shorted and LV is given with supply, what is the wattmeter reading? Generally, wattmeter reading indicates the full load copper losses, na? Because under short circuit test, anyhow, the current is going to be rated current. Until unless this, even though it is not rated, this can drive rated current. If it is short circuited, a small voltage is enough to drive the full load current. So majorly the wattmeter reading is going to be full load copper losses, and minorly it is going to be small iron losses. Full load copper losses of high voltage winding and low voltage winding, because in the low voltage winding also full load current is going to be circulated. In the high voltage winding also it's a rated current is going to be circulated. So the two copper losses, the two winding copper losses, rated copper losses will be included, and it will be represented or indicated by the wattmeter. And whatever the winding which you short circuit, here also if you short circuit high voltage winding, full load current will circulate. Here also low voltage winding, full load current will circulate. So here also rated copper losses, here also rated copper losses. Then the wattmeter again indicates rated copper losses only. There is no much big difference in wattmeter reading. It will be indicating again same 20 watts. Does it make any difference? Wattmeter will show the same losses. Okay. 20 watts. Okay. Right. Anybody has doubt? Anybody has doubt in this one previous question? Right. Let us see one more thing. Let us see one more question. For a three-phase slip ring induction motor, the electrical rotor losses are proportional to. If you remember the power flow equation, this is rotor input and rotor copper losses, and this will be gross mechanical power. Okay. So the relation between the rotor input, rotor copper losses and gross mechanical power is taken as 1:S:1 -S. So if you write the rotor copper losses in terms of rotor input, I can write rotor copper losses are depending upon the slip parameter. Rotor copper losses are proportional to rotor input. Okay, it is depending upon the slip parameter. So I cannot write in proportional to because slip cannot be constant generally until unless you fix the load. So rotor copper losses are depending upon slip factor, not synchronous speed, air gap power, none of the above. Okay. Right. Next, if you look at this question, blocked rotor test of a squirrel cage induction motor determines. Blocked rotor test is same as short circuit test in the transformer. Okay, in the transformer we conduct short circuit test to find the copper losses in the windings. Same way here also copper losses you can find out. But same like we apply less than the rated voltage and we will circulate full load current so that you will get full load copper losses on the stator side and full load copper losses on the rotor side. But the stator losses are going to be very minimum because we are applying lesser voltage. Okay. Now that means I am trying to say if from blocked rotor test we are going to, it is equivalent to short circuit test of a transformer, and you are going to find out the winding losses simply. Winding losses. So where is the winding? Winding is there on the stator as well as rotor. So winding, stator winding parameters and rotor winding parameters you can see. So it is going to determine its equivalent series resistance and reactance as seen from the stator. equivalent shunt resistance and reactance as seen from the stator, equivalent series resistance and reactance as seen from the rotor, equivalent shunt resistance and reactance seen from the rotor. No, it is not actually from rotor side calculation, obviously from the where we connect the voltage source, from there only you can see. No, to the stator we will connect the voltage source. So the equivalent resistance and reactance is seen from the stator side, not from the rotor side. So any one of these going to be the correct answer. Now are we going to calculate shunt branch parameter? Open circuit test, no load test will give you the shunt branch parameter, not short circuit test. So shunt branch parameters we do not get. We get series branch parameter, that is leakage reactance and resistance of the winding. So A could be the proper answer. Okay, is that clear for everyone? Come on guys, respond if you have any doubt at any point. You just ask me, please post your comments so that I'll take up your doubts also. Look at this question. A synchronous motor is operating at constant load. Load is constant. While its excitation is adjusted to get unity power factor. Okay. At constant load, the excitation is adjusted to get unity power factor. Now, if the excitation is now increased, the power factor will be. So, if you remember the V curves and inverted V curves, you can do it easily. This is my field current or excitation, and here you can take a power factor or otherwise armature current. Generally, the armature current versus excitation will be of V curve. Armature current versus excitation. Okay. When it comes to power factor, the power factor versus excitation will be of inverted V curve. So highest value of power factor is what? Unity. Least value of power factor is what? 0. So generally at unity power factor, this is going to be normal excitation. So he said the synchronous motor is operating at a constant load and its excitation is adjusted to unity power factor. So at this point it is operating. At this point it is operating. So the armature current drawn by the motor is going to be minimum. Now he is asking if the excitation is now increased. If the excitation is now increased, so normal excitation, instead of normal excitation, we are increasing the excitation. If you increase, it will become an over excitation synchronous motor. Under this region, in the over excitation region, the power factor is going to decrease, whereas the armature current is going to increase. So instead of unity power factor, it will operate at 0.9, it will operate at 0.8, it will operate at 0.7, like that. Instead of small armature current, it will draw large armature current. But he did not mention anything about the magnitude of power factor or armature current, but he is asking about leading or lagging. Then you should understand. Over-excited synchronous motor, where under which power factor it will operate. If you take up the this one, phasor diagram, if it is unity power factor, then IA will be like this. IA will be like this. So what is the loss? What is the drop? The synchronous reactance drop. Okay. So V minus synchronous reactance drop, that is IA excess, will be equal to the induced EMF. Will be equal to the induced EMF. This is my E. Okay. Right. What I am doing now, I am increasing the excitation. If the excitation increases, E also increases. No. E also increases. No. If the excitation increases, E increases. If the excitation increases, coupling also increases, because magnetic field increases. Rotor is going to possess more field. So the locking is going to be very much strong. If the locking is very much strong, delta decreases. Earlier delta this much and now delta this much. There is an increment in EMF magnitude and there is a slight decrement in load angle also. Now if this is a E, then IA excess drop will be, I can draw like this. This is my IA excess drop. Now where will be IA? IA excess drop should be perpendicular to IA, na? Because reactance drop is 90 degrees with respect to the current component I can write. So if this is my IA excess drop, now the current component will be like this, maybe, probably, or like this. Then only I can draw IA excess drop component like this, no? So this is my IA component nu. So with respect to voltage, the current leads with respect to voltage. So it's no more lagging, it's actually leading power factor. Very good, Abhishek. It is leading power factor. Otherwise, if you remember, an overexcited synchronous motor will deliver the reactive power and operates at leading power factor. Generally, this is called as synchronous condenser, na? Synchronous condenser. So capacitor, obviously leading power factor. If it is behaving like capacitor, the operating power factor is going to be leading. So that's all, some questions from machines, and let us look into measurements questions. The working principle of thermocouple. The working principle of thermocouple. So this is my heating element. This is my heating element, and here is my the meter which is going to absorb this, or which is going to sense the heat, right? So it's like, obviously heat transfers from hot body to cold body. So this is my hot body and this is my cold body. So cold body receives the heat, and therefore your the pointer of the instrument is going to be indicate some value. What is this? This is same as like Seebeck effect, na? Working principle of thermocouple is based on Seebeck effect. Hot body to cold body, right? Very good. Pavan, Ashok and Abhishek, very good. Can you tell me about this one? One cycle of square wave signal observed on an oscilloscope. So let me take up one cycle of square wave. So let me take up square wave, positive pulse and negative pulse. So he has given one cycle. Is found to occupy 6 centimeters at a scale setting of the time setting of 30 microseconds per centimeter. If this wave is occupying 6 centimeters, what is the time duration then? So the time duration will be 6 centimeters into 30 microseconds. Microseconds per centimeter. Centimeter can be cancelled. 6 3s are 180. 180 microseconds. So the square wave duration is of 180 microseconds duration. Total time period, not half cycle. I got total time period. Now what is asking, what is the signal frequency? If the time period is 180 microseconds, then can't you calculate frequency? 1 by 180 into microseconds. So if the micro goes up, it will be 10 to the power of 6. So 110 cancel, so 10 to the power of 5. I can write 100 into 10 to the power of 3 divided by 18. So this is my time period. 10 to the power of 5 can be written as 100 into 10 to the power of 3. Na? So what is the nearby answer? Nearby answer 416 4 4s are let me take up it as around 100 by 20. So around nearby 5. Is it coming out as nearby 5? So if I make 18 as 20, then it will be 5 kilo. Not actually, this is 20 kilo. No, the denominator value is not 20. So it is actually less than 20. If it is less than 20, answer should be greater than 0.5 kilo. Greater than 5 kilo you should get, not 55. So B could be the correct answer. Very good. Pavan, Abhishek, Ashok. All right. two equal voltages of same frequency applied to X and Y plates of CRO produce a circle on screen. Voltages are same and the frequency of voltage is also same. So time period of voltage signals also going to be same. If the image is going to be circle on the CRO screen, then what is the phase difference? So remember, if the phase angle difference is 0, then the image is a straight line or a diagonal line you can take up. So let me take up this phase angle difference. The phase angle difference between the two signals, if it is 0, then it will be a diagonal line or otherwise a straight line at 45 degrees with respect to x-axis. If it is 180 degrees, 135 degrees with respect to x-axis. It's a straight line at 135 degrees with respect to x-axis. Now if it is 90 or 90 or 270, then it will be a circle. But there is a small difference. It will be clockwise and this will be anti-clockwise. Okay. So circle means it can be 90 or 270. So 270 is not given, only 90 is given. Other than 90, 270 is 0 and 180. So in between, if phase angle is less than 90 and greater than 0, it will be an ellipse. Here it will be an ellipse. Phase angle less than 180, greater than 90. Here it will be an ellipse. Phase angle less than 270, greater than 180. Here also it will be an ellipse. Phase angle less than 360 and greater than 270. So ellipse, these are going to be ellipse. So it can be any of these phase angle. So they'll give you, sometimes they'll give you phase angle, they'll ask you the image, and sometimes they'll give you the image, they'll ask you phase angle. All right. So these are some questions on electrical measurements, machines, power systems. I think we took around 6 questions. Huh?
Okay, so let's start the EMFT part, and this is the first question in front of you. So let's start the EMFT part. So in this question it is given that a 50 megahertz uniform plane wave is propagating in a material with permeability and permittivity is given. So this is your mu r and this is your epsilon r. You have to consider the medium as a lossless and the phase constant you have to calculate. So beta is equal to, you know that, what is that? Omega upon c root over mu r into epsilon r. So omega is 2 pi into frequency, that is 50 into 10 to the power 6 divided by 3 into 10 to the power 8, and root over mu r into epsilon r, that means 2.25. So if we will solve it, we will get this 2 into 50, 100, and this is 10 to the power 8, so it will get cancelled. So we will get 5, here 1.5 and 3. So that is nothing but a pi by 2 radian per meter. So that is the answer you will get. So correct answer will be option C. Now coming to the next question. A non-magnetic lossy dielectric material with the relative permittivity epsilon r is given again. Conductivity is also given, is applied with the electromagnetic wave with the frequency 2.5 megahertz. What is the loss tangent? So the formula for the loss tangent is sigma upon omega epsilon. So here we will get sigma, which is 10 to the power minus 4. Omega is 2 pi into f, that is 2.5 into 10 to the power 6 into 2.5 into 10 to the power 6 into what? This is 2 pi f, epsilon naught into epsilon r. So this is 2 pi and epsilon r, that is 10 to the power minus 9 divided by 36 pi. So after solving this,
This is the sigma upon omega epsilon loss tangent. So when you will solve it, you will get the answer as 0.32. So that is the direct formula based question. It is loss tangent that we need to calculate. Now a solid conductor with the relative permeability mu r is given to you. Conductivity is also given to you. The diameter and length is given, but we want to calculate the skin depth. So because it is conductor, for the conductor, what is the skin depth? The skin depth is given by alpha is equal to, delta is equal to 1 upon alpha. Delta is equal to 1 upon alpha. So delta is equal to 1 upon alpha, and alpha is given by pi f mu sigma in case of conductor. So this is 1 root over, you have to substitute all the values like pi, f is from here you can calculate the f, this is omega, it is given, so omega is equal to 2 pi f, so this is pi into 10 to the power 4 divided by 2 pi multiplied with, this is f, mu is mu naught into mu r is 200, and the sigma is 5 into 10 to the power 6. So after solving all this, you will get the answer as 0.225 millimeter. Okay, so that is the correct answer, option number B. Now coming to this next question, what is the standing wave ratio in terms of reflection coefficient? So standing wave ratio in terms of reflection coefficient is 1 plus magnitude of gamma, that is the reflection coefficient, and 1 minus magnitude of reflection coefficient. So according to this relation, the answer is option C. But sometimes you can also calculate the relation from the standing wave ratio. If suppose standing wave ratio is given, you can calculate the reflection coefficient as well. What is the range of a standing wave ratio? The range of the standing wave ratio is 1 to infinity. What is the range of reflection coefficient magnitude? That is less than equal to 1. So these all values should also be known. Okay, it is also equally important. Now in this question, a capacitor is made with a polymetric dielectric having a relative permittivity of epsilon r is equal to 50, epsilon r of 2.26 with the dielectric breakdown strength. So dielectric breakdown strength is also given to you. Now according to that, that is epsilon 2.26 is given. Okay, this is 2.26 dielectric strength is given to you. So try this question. I have told you a few questions, now you have to try. Come on, quickly solve. This is the question. Dielectric breakdown strength means electric field, as you can see from the unit also. Area also you can calculate. Okay. See, the electric field strength is given. You have to calculate the maximum electric charge. So we can say that this we want to calculate Q equal to CV. This we can think of, or what you can think of is the charge. So what is the charge? What will be the charge? Charge is nothing but a Q rho s upon epsilon, right? Rho s upon epsilon. You can say Q upon epsilon naught A. Right? Now solve this one. See, electric field strength is given. That means the E is given to you. Okay. So 50 kilovolt per centimeter is given. Now, how can you calculate this capacitance? So this capacitance, because the capacitor is given, so this capacitance is nothing but a epsilon naught, epsilon r, A upon D. Correct? Epsilon naught, epsilon r, A upon D. That is given to you. Now the potential, how can you write the potential? The potential is nothing but a E into D. Correct? The potential you can write it as E into D. So that is all you have to substitute. So this D and D will get cancelled. So this C is equal to epsilon naught into epsilon R into A into E. Correct? So this is the capacitor. Now what you can do, this epsilon naught, epsilon R, everything is given to you. Now you can calculate the value of C. Okay? And substitute the value in this equation. Come on, tell me what will be the answer for this now. So put the values like this C is equal to 8.854 into 10 to the power minus 12. Epsilon R is 2.26. Now you have to calculate the area, that is your 20 into 40 into 10 raised to power minus 2, and the electric field is even if you cannot want to calculate in the centimeter because all the dimensions are also in the centimeter, so you can directly write 20 into 40, that is 50 into 10 raised to power 3. So by here you will get the capacitance. Are you getting the answer? Yes, after solving this, you are getting 8. Okay, after solving the capacitance, substitute the value of capacitance here, and this is nothing but a Q, no? This is nothing but a Q. After solving this, you will get 8 micro. Because Q equal to CV was there, and I have substituted the value of C, which is this one, and this is the value of V. So this is Q equal to CV. So you will get Q equal to CV from here. This is the equation from where you will get the values. When you substitute all the values, you will get 8 microcoulomb. Now coming to the next one, a solid non-magnetic conductor of a circular cross section having its axis on the z-axis and carries a uniformly distributed total current of 60 ampere in the AZ direction. If the radius of the conductor is 4 mm, find the magnetic flux density at rho equal to 5 mm. That means we want to calculate the electromagnetic flux density. Flux density means B. B is equal to mu h. And what is the magnetic field because of the conductor of finite radius? This is 2 pi into rho. Because the radius is less, the radius is 4 mm, and we want to calculate the outside the conductor, so we can use the direct relationship, and this is mu naught into mu r if it is given. Non-magnetic it is given, so this is mu r equal to 1 and I upon 2 pi rho. So mu naught is 4 pi into 10 to the power minus 7 and mu r is 1. The current, how much is the current? Current is 60 ampere divided by 2 pi into rho, that is 5 into 10 to the power minus 3. So when you will solve it, you will get the final answer. So how much you are getting after solving this? Yes, after multiplying this 2 pi and this 2 will get cancelled, and when you will solve it, this 5 and 12, so 12 into 2, 2.4. So that is the answer, 2.4. So 2.4 millitesla. Okay. Yes. Now coming to the next question, the magnetic flux density in a magnetic material with the susceptibility chi m is equal to 6 in the given region as B is equal to 0.005 y square. Find the magnitude of current density at y equal to 4. So first of all, you should know that how can you get the current density? The current density is nothing but the curl of B divided by mu. So now we have to calculate the curl of B. The B is given. So the curl of B, that is the Maxwell equation which we are using. Okay. So curl of B we are calculating. So this is AX, this is AY, this is AZ, and del upon del X, del upon del Y, del upon del Z. X component is 0.05 y square and the rest are 0. So you will get the Z component. You will get the Z component and it is nothing but a plus 0.01 y. Okay, and when you put y equal to 4, you will get 0.0 AZ cap. So that is the value of 0.04, and because we have to divide it by mu, so that is J is equal to curl of B, we have got 0.04 into AZ divided by mu. Mu is mu naught into mu r. So how do you get this mu r? The mu r is nothing but the 1 plus chi m AZ. So ultimately we are going to get 0.04 divided by 4 pi into 10 to the power minus 7 into 7. So when you will solve it, you can easily see, and it was also given, you can easily see that it is something which is 7 pi coming in the denominator. When you will solve this one, you will get 0.01, and when it will go up, it is 10 to the power 4, and this 7 pi will be left in the denominator. So answer will be option A. Next is the internal inductance of a straight line. What is the direct relation? This is the direct relation, internal inductance, if you want to calculate because of the straight line. So that is the direct relation. We are not deriving. This is some kind of derivation. So if you know the answer, then you can directly do this. Otherwise, you have to derive it by simply 1 by 2 B square divided by mu. Okay. Yes. Now the density of the energy density, if you want to calculate the energy density, that is energy per unit volume. So energy divided by volume, energy is half into mu into h square. So 1 upon 2, mu is 4 pi into 10 to the power minus 7 into h square means 10 to the power 6. So what is this value? 10 to the power is 6. Yes, so we will solve it. We will get 2 pi, and if we want to calculate in the millijoule, this actually answers, this is in the millijoule. The option number C is in the millijoule. So answer will be 628 millijoule. Now 2 millicoulomb positive charge is located in the vacuum at the point P1 is equal to 3 minus 2 minus 4, and 5 microcoulomb negative charge is located at the point. What is the magnitude of the force? So we just need to calculate the force between them. What is the magnitude of force? So the force is given by Q1 Q2 upon 4 pi epsilon r square. So Q1 is 2 millicoulomb, and this Q2 is 5 microcoulomb divided by 4 pi into epsilon naught, that is 10 to the power minus 9 divided by 36 pi, and now we need to calculate the distance between them. So the distance between them is 3 minus 1 2 minus 2 plus minus 4, that is plus 2, it will become, and minus 6 is that. So the distance is magnitude is square. So let's take the magnitude, that is 2 square plus 2 square plus 6 square. That is nothing but a 44 root over 44. So square when we will perform, that is 44. So after solving the equation, what we will get? this is 18 into 2 36, and this is 32 or 22. So we will get something around 90 upon 22. 19. Okay, sorry, this is not 18, this is 4 pi, no? This is not 2 pi, so this is 9. So this is 45 into 10 to the power. This will also get cancelled, so this is not come. 45 into 45 divided by 22. So 2.04. Yes. So 2.04 will be the answer, right? 2.04 is the approximate answer. 45 divided by 20. 10 raised to power minus 9 will also get cancelled. Now we have the 4 sheets. The 4 infinite uniform sheet of charge with the following uniform charge density are placed at different points in the space. So there are 4 charges given. We need to calculate the electric field at y is equal to 6. As you can see that all the sheets are placed in the y equal to constant plane, that is xz plane. So that means the direction will be in the direction of y. So the total electric field will be rho s. Rho s means the charge density, which is 20. So let's write 20 into 10 raised to power minus 12 divided by 2 into epsilon naught, and the direction y equal to 7 to y equal to 6 is negative, so minus ay. And this is y equal to 3 and y equal to 6. We are going in the positive direction, so minus 8 into 10 raised to power minus 12 divided by 2 epsilon naught, and this is ay. And y equal to minus 6, that means positive, so plus 6 into 10 raised to power minus 12 divided by 2 epsilon naught. Y equal to minus 1 to y equal to 6 means we are going into the positive direction, and then minus 18 into 10 raised to power minus 12 divided by 2 epsilon naught. Y equal to minus 4 to y equal to 6 is also positive direction. So when you will solve the 10 raised to power minus 12 and divided by 2 epsilon naught, all are constant and common, and we will solve it, and when we will solve you will get the answer as 18 pi. Okay. Now coming to the next one. A 25 microcoulomb point charge is located at origin and electric flux passing through the sphere of portion this. So the point charge is located in the origin, and the electric field we want to we have in 20 centimeter radius is given. So how do you calculate the flux? The flux is nothing but the charge. Okay, the flux is nothing but the charge, electric field line passing through some area. So first of all you have to calculate the electric field. Okay, so the electric field dot ds, E dot ds, when you will calculate the flux passing through the portion of the sphere, that means the flux is given by psi, so that is integration E dot ds. Okay, so you can calculate it, and because the space that is not given to us, so q upon this is E dot ds or D dot ds, anything we can use. And if the space something is not given, that in which space it is written kept, so we can use the D dot ds, because we don't have the exact definition written right now. Like in the gate they have asked already about the E dot ds. So E dot ds is also the flux, but in that case when you write the E dot ds, then in that case the charge enclosed divided by epsilon naught you have to use. But if you are using the D dot ds, then the charge enclosed you have to use. That is the only thing. And because the electric field is given by, this is k q upon r square, and this is 1 upon 4 pi epsilon naught into q upon r square. So when you want to write the d, so d is nothing but the q upon in the direction of r, so q upon 4 pi r square in the direction of r. And then what about ds? ds in the direction of r, because it is r equal to 20, so it is going in the r direction, so this is nothing but the If it is going in the direction of r, then it is r d theta, or simply you can write r square sine theta d theta d phi. Right? This is what we have to calculate. This is, sorry, d, and this is ds. So the flux you can calculate like double integration. D value of d is q upon 4 pi r square. So this is 4 pi r square, or you can write a small r. This is, you can write small r because that is the variable part. R square. So this, because here I have used a small r, so that's why I am using this. And what is this? AR and dot product with AR cap r square sine theta d theta d phi. So this r square and r square will get cancelled, and AR dot AR is 1. So we will get q upon 4 pi, and it is sine theta d theta d phi. The limit is from theta equal to 0 to pi, and phi is from 0 to pi by 2. I think it is pi by 2, not 2 by pi. Yes, it is pi by 2. Okay, this is pi by 2. So the value of charge is given, the value of charge q is given, and rest of the things only we need to integrate and calculate. Substitute the value, you will get the value as 6.25 microcoulomb. That is our answer. Option number C. Got it? Yes. Q upon 4 pi we can take common. Sin theta we can integrate from 0 to pi, and phi, that means pi by 2 only. Okay, because when you integrate, you will put upper limit, you will get pi by 2 only. Now, a dielectric material is placed in vacuum in a uniform electric field of 4 volt. What is the electric field inside the material if the relative permittivity of the dielectric is 2? So that is the question from the boundary condition, because previously it is placed in vacuum. Now you are inserting or keeping this in the material. That means it is the boundary which is changing. So how will you solve it? So this is epsilon r equal to 1 initially, and the epsilon r2 is equal to 2 because the dielectric material is given. So now we know that the normal component of electric field is same. So you can write epsilon naught epsilon r1 normal component, and epsilon naught epsilon r2 normal component. So epsilon naught will get cancelled. This is 1 into, previously electric field was 4, and now the electric, this is 2, right? Yes. So En2. Now you can calculate the value of En2. It is 2 volt per meter. So answer is option C. So you have to use the boundary condition, because the normal component of electric field will be there when you placed in the vacuum and to the medium. Now this is the similar type of question that we have already solved. Energy density is given, and this time electric flux density is given. You need to calculate the permittivity. What is the formula? That is the similar formula that we have used for the magnetic field. So for electric field, energy density is 1 by 2 epsilon 1 by 2 epsilon E square, right? And D is equal to epsilon naught E. Okay, D is equal to epsilon naught E. This is the D. D is equal to epsilon naught E. So we can write E is equal to D upon epsilon. So D upon epsilon whole square 1 by 2 into D square upon epsilon. Now the energy density is given, which is 20. 1 by 2. What is the value of D? D is 15 into 10 raised to the power minus 6 whole square, and divided by epsilon. Epsilon can be written as epsilon naught into epsilon r. So from here you can calculate the value of epsilon r, because epsilon naught you can substitute and you can calculate the value of epsilon. Let me write over here. This is 20 is equal to 1 by 2 into 225 into 10 to the power minus 12 divided by 8.854 into 10 raised to the power minus 12 into epsilon. So this 10 raised to the power minus 12 will get cancelled. So from here you can easily calculate epsilon r is equal to 225, that is 2 into 2 into 8.8. So you can approximate into 9, 9 into 2, 18, 18 into 2, 360, 360 divided by 225. So it will be less than 1. 360 divided by 225 would be less than 1. and it is coming as 0.6. So answer is 0.6. Okay, got it? Now, this is very easy one. The direct continuity equation we have minus of rho v upon epsilon naught. Which one of the among equation is true for the steady state magnetic field? For the steady state magnetic field, which one will be correct? Option C. Okay, option C, because that is the Ampere's law. If it is the time varying field, then the displacement current density will also come. What is the answer of this question? Okay, this is the question from EDC now. This is the question from EDC, that is the electronic devices, so we can leave it. That is also like, what is the value? Ideal conductor has the static electric field intensity inside the zero, always inside the conductor it is always zero, and static field intensity will be always directly normal to the surface. Is it correct or not? Outside conductor is zero? No. Inside it is zero. And outside it has only the normal component. Right? That is why we calculate the normal component dn1 equal to dn2. Now, wavelength, simply wavelength is lambda is equal to Vp upon F. Velocity upon frequency. What is the velocity? Velocity, this is the frequency which is given to us. Is there something which is missing? I think some data is missing here. Yes, what do you think? If you read this question, are you feeling something which is missing? Yes, if velocity is not given, then it will be taken as the velocity of light, because it is given as the air. So because it is given as the air, so phase velocity will be equal to velocity of light. Absolutely correct. And it is, remember that it is not the F, it is omega. The question, in this question it is given as, this is not the F, it is omega. So don't forget to take this pi. So this will be 3 pi upon 10. So answer is option number D, correct. Now a lossless transmission line segment has the characteristic impedance Z0 is equal to 100. Electromagnetic wave propagation velocity in the transmission line is V is equal to 0.8 times of the velocity of light, and the beta L is equal to pi is given, the frequency is given, we have to calculate the length. So beta L is equal to beta, length we want to calculate. So length is equal to pi upon beta. How can you calculate the pi? Pi is nothing but the Vp upon beta is equal to what? Omega upon Vp, right? Beta is equal to omega upon Vp. This is omega divided by Vp. So pi into Vp. Vp means 0.8 times of velocity of light, that is c. What is omega? Omega is 2 pi into f. F is 100 into 10 to the power 6. So if I substitute all the values, the pi is into 0.8 into 3 into 10 to the power 8 divided by 2 pi into 10 to the power 8. So 10 to the power 8, 10 to the power 8 will get cancelled. This pi and this pi will get cancelled, and length is coming as 1.2 meter. 1.2. Now what is the volume charge density if the electric flux is given? So again, using the equation of the Gauss law, that is the Maxwell equation, you can say, derived from the Gauss law, divergence of D. So we have to differentiate the x component and y component and the z component. This is y square plus x square plus 1. And we want to calculate 1 to 1. So 2 square plus 1 square plus 1. 6 coulomb per meter cube. Answer is. Now coming to the question number 57th. Yes, electric field is given to us. Incremental path is given. Find the work done. So work done is nothing but a force into displacement, right? Work done, if you want to calculate the work done for a short distance, that is nothing but the force, that how much force you are having or the charge is exerting, and then displacement. So that is given to us. The F we can write whenever the charge is placed, the charge 4 coulomb will bring in this particular electric field that will experience the force. So that is Q into E with minus sign dot delta L. The minus sign, this is given, and E dot dl you can easily calculate. The dl is also given. Okay, the dl is also given. So if I substitute all the values, let's substitute this. Minus charge is 4 into 10 to the power minus 6, and E dot dl, that is zy square ax cap plus 2xyz ay cap plus xy square az cap. Okay, and this is dot product with minus 3ax plus 5ay minus 2az minus 2az. Bracket close. So when you will take the dot product, you will get minus 4 into 10 to the power, because this is also given in the micrometer, so this is minus 12, and the point is 111. So when you will calculate, you will get minus 3 plus 10 minus 2. So 5 into 4, so that is 20. So 20 picojoule, and this is positive, so this is negative. 20 picojoule negative. So minus 20 picojoule we will get. Okay, just take the dot product and put these values 111 here. So that is nothing but a 111 means all are 1. So this will become 1. This will become 2. So that is how you are getting. Okay, so this will, let me write in the red pen. So this is 1 into 1. So that is 1. And this is 2 into 1 into 1. So that is also 2. And this is also 1. So this is 1 you are getting, this is 2 you are getting, this is 1 you are getting. So 1 multiplied with minus 3 you get minus 3, 2 multiplied with 5 you get 10, minus 2 multiplied with this 1 you will get minus 2. So after solving this you will get 20 picojoule. And because this distance is in micro, so it is 10 to the power minus 6 which we have written, and this 10 to the power minus 6 will become 10 to the power minus 12. Now we want to calculate the zero voltage at infinity. Find the potential T0010 that is caused by the charge distribution 10 nanocoulomb. So that means because of the line charge we want to calculate the potential. Okay, so the potential will be given by integration over the length L. The range is given, so that is your rho L dl upon 4 pi epsilon naught into R. Because the electric field is given by 2 pi epsilon naught, then when you differentiate it you will get this one. So just you need to solve for the given range. So suppose the R12 is how much? This is Z which is variable, here is 10 which is variable, rho L is given, so this is 10 into 10 to the power minus 9. You have to integrate it with respect to L, and the 4 pi epsilon naught is common, and the distance R is 10 minus Z. Okay, the Z is varying from minus 1 to 1. So 10 into 10 to the power minus 9 divided by 1 upon 4 pi epsilon naught can be written as 9 into 10 to the power 9, and when you will integrate it you will get log 10 minus Z, limit from minus 1 to 1. Okay, so this 10 to the power minus 9 and 9 will get cancelled, 90 you will get. So natural log of 1 when you will put, you will get 11, and natural log of this 9 you will get, and natural log here, and you will get minus 1. When you will substitute, you will get 11. So this is 9 minus 11. So 90 log 11 minus 9 with minus sign. Minus sign. Minus sign will also come now, because we are different. We are integrating with respect to z. So because of this minus, that the minus sign will also come. So when you have integrated it, this minus sign will also come. So because of this minus sign, you can write 90 and then natural log of 11 minus natural log of 9. So how much it is when you are solving? It is, yes, 18. Correct. You are getting. Now we want to calculate the dipole moment. What is the dipole moment? Dipole moment is denoted by P. P is nothing but the charge into distance. So what is the charge? Charge is 3 and the distance between them is 2. So that is nothing but a 6. Okay. The distance is between 1 to minus 1, it is 2. And the distance or the charge is given in the micro. So you will get 6 microcoulomb meter. That is nothing but your dipole moment. Now simply that is the distance between the 2 points. So you can calculate any one of this in the form of either Cartesian or the cylindrical, spherical. So this is r theta phi, which is a spherical form. So how you can calculate this x? X is nothing but a r. Tell me, r cos theta. Okay, and y is equal to, this is r cos theta sin phi, correct, and this is r sin theta sin phi, and z is equal to r cos theta. So that is how you can calculate. The r is 4, cos theta means the cos 30 and sin 120, and this is 4 sin 30 cos, sorry, sin 120, and r cos theta means 4 cos 30. So when you will get the values of x, y, z, and after getting the value of x, y, z, what you can do, you can calculate the distance. What is the formula for the distance? Root over x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. So cos 30 1 by 2. This is also 1 by 2. So you will get minus 1. So from here you are getting minus 1. Wait, I think I have written the wrong answer, because it is how it is coming as minus. X is equal to rho cos phi. So yes, it is r sin theta cos phi. Y is equal to r sin theta sin phi, and z is equal to r cos theta. So r is 4 sin theta, theta is 30 cos phi 120. So this is minus 1 by 2, 1 by 2, yes, minus 1. So r is 4 sin 30 sin 120. So cos 30 again, cos 30 means root 3 by 2. So yes, 4 by 2 into root 3 by 2. So we will get root 3. And r cos theta, so 4 cos 30 means 4 upon cos 30, 4 by 2. That is 2 into root 3. 2 root 3. Root 3 by 2, na? Cos 30. Now that point we have this. Now the distance is, let us suppose this is x1, y1, z1, and these are x2, y2, z2. So you can calculate x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So x2 is minus 1 minus 3. So minus 3 whole square. Y2 is root 3 Phi 1 is 3. So root 3 minus 3 whole square. This is 2 root 3 minus of minus 1. This is plus 1 whole square. And the distance is 5.53. 5.53 is the right answer. Okay. So this is it from my side, guys. So EMFT, all the questions of ISRO 2020 we have solved. And if you have any doubt, you can comment in the comment section. Else we have almost end up the session, right? So you can easily solve the questions. You can see that how easily we can solve the questions of ISRO. So that is not tough. You can easily solve. Yes, guys. So thank you for watching this session. Stay tuned with us. Don't forget to subscribe the channel. And there is a scholarship test tomorrow at 12 o'clock. So you can register yourself for the scholarship test. The link is given in the description box. And we are also running the different series. So subscribe our channel to get updated for the upcoming series. Thank you.